everyone, and welcome back to the tutorial series. In this video we will be working on the Unreal Engine game client, specifically connecting the client to the client service. In the last part of the tutorial we made various AWS Lambda functions and various Amazon API gateway endpoints for each of those functions. After this video, the client should be set up to call these API gateway endpoints, thereby invoking the Lambda functions. The client will do this by sending HTTP requests to the API, and the API will send HTTP responses back to the client. Finally, a combination of these API responses will be used by the client to join the game server hosted on an Amazon EC2 instance. And one more thing before we begin, if you have made it this far in the tutorial series and want to help support the channel, then please consider becoming a patron on Patreon. We appreciate every single donation, no matter the amount, because it helps us create more content. Now let's get back to the video. So the first thing that I'm going to do is go to the Amazon GameLift dashboard, and once you are here, click on the name of your fleet under where it says fleets. And the reason that we are doing this is that we want to make sure before starting this video that your fleet from earlier in the tutorial series is still active and has at least one active instance with at least one active server process running. The reason that I want to confirm this is that in the comments of an earlier part of the tutorial, I recommended setting the number of running instances to 0, essentially manually scaling down the fleet. To do this, make sure that you have the scaling tab selected here and scroll down to where it says auto scaling policies and where it says manually adjust the desired instance count to some number. In my case, that number is currently 1. And here you can change the number of instances running currently to 0. This is to avoid getting charged for when you are not using the fleet. Amazon charges you for the amount of time that you are running active EC2 instances. The amount you are charged for depends on the number of EC2 instances running and how long they are running for. We will eventually have a separate video detailing more information about GameLift pricing. Because these videos have taken a while to get made, there may have been a long period of time when the fleet was idle, meaning that the instances in the fleet were idle. Idle in this case means no active game sessions were being hosted on the server processes running on these instances in this fleet collection. When you know that your fleet is going to be idle, I would recommend setting the desired instance count number here to 0 so that you are not getting charged. However, for this part of the tutorial, the fleet will not be idle. So if this number here says 0, make sure to change that back to 1 before proceeding with the rest of this video. Because when the client gets into a match successfully, GameLift will need an available server process running on an active EC2 instance in order to host a game session for that match. Otherwise, there won't be any running game servers and the client will not be able to join a game. Then, remember, if you do change this number by where it says manually adjust the desired instance count to, you will also have to click a checkmark button that will appear after changing this number to apply those changes. And even after changing the desired instance count to 1, make sure that up here by where it says active instances and active servers, that you have at least one active instance and at least one active server running like shown on my screen. This UI is not reactive, so you will only see these two numbers change if they do change after refreshing the page. If everything looks similar to what you see on my screen, then let's go to our Unreal Engine game project directory in File Explorer, and from here let's go to the content folder and then the URLs folder, and let's make a new text file by right clicking here and selecting new and then text document. And we'll name this text document region code and then press enter to finish naming that text file, and then proceed to open that text file in the text editor of your choice or preference. It doesn't matter which text editor you use to edit this file in. And in here we're going to type out the code of the AWS region where you are operating in. So for me, for instance, I am operating in the US East Northern Virginia AWS region. So I'm going to type out the code for that region, which is US-East-1, and press Ctrl S to save. Now, despite having this text file containing a non-URL piece of text in a folder called URLs, the purpose of this text file is that in order to calculate the network latency between the client and AWS, we will be calling the AWS service endpoint, specifically the one for GameLift. This latency value will be used to populate the latency map that we will be passing to a call to the GameLift start matchmaking function, like how we talked about in the last part of the tutorial. Generally, the URL of the service endpoint follows the same format across multiple regions and even across multiple AWS services. Since we are focusing on just GameLift, the only variable of the endpoint route that changes is the region code. So once we're done with that, we can close this, go back to the main project directory where the uProject file is located. Now, it has recently come to my attention that certain VR plugins that we are not using are enabled by default when making a new Unreal Engine project. So let's open up the Visual Studio solution file for our Unreal Engine project so that we can edit the uProject file in Visual Studio in order to disable a couple of plugins. From here, go to the Solution Explorer on the right side, find the uProject file and double click it to open it up. Now, like I just mentioned, we are not using a couple of VR plugins that are enabled by default, so there's no reason to build nor package them with our project. So let's disable these by typing out inside this plugins array after the last plugin object a comma, and then on the next line some squiggly brackets, and then inside these type out in quotes name colon in quotes Oculus VR, and then comma in quotes enabled, and then colon false, and then another comma here at the end after this closing squiggly bracket. Type out another pair of squiggly brackets, and inside here type out in quotes name, and then colon in quotes Steam VR, and then comma in quotes enabled, and then colon false. Note that you could have also disabled these same plugins inside the Unreal Engine editor, similar to how we enabled the web browser widget plugin earlier in the tutorial. I simply chose to achieve the same effect by modifying the uProject file in Visual Studio instead to show you guys another way to enable and disable plugins in your Unreal Engine project. Also, I recently updated my Visual Studio, so I have to rebuild my project anyway, and I did not want to build my project with these plugins, so once you're done, make sure you have the Development Editor solution configuration selected, as well as the Win64 solution platform. Then go back to the Solution Explorer, right-click your project under the Games folder, and select Build. And once your project is finished building, go back to File Explorer, specifically where your project is located, and double-click the Unreal Engine project file to open it up in the Unreal Engine editor. Once the Unreal Engine editor has opened up, just to double check that those VR plugins were disabled, let's go up to where it says Edit, click on that, and then from this drop-down menu at the bottom, click on Plugins, and then on the left side of this new pop-up window, scroll down to where it says Virtual Reality, and then select that. Now on the right side in this pop-up menu showing a list of virtual reality plugins, you will notice that if we scroll down, both the Oculus VR and the Steam VR plugins do not have a checkbox by where it says enabled, meaning that they are both disabled. If you have free time, feel free to browse all the built-in plugins and make sure that only the ones that you are actually using are enabled, because if you enable a plugin like a virtual reality plugin that you are not using, then it just increases your build and packaging time for no reason. You can filter all the built-in plugins to only show your enabled plugins by making sure where it says built-in on the top left corner is selected, and then clicking on the eye icon on the top right corner and selecting show only enabled. And if you think that some of these plugins should be disabled, then you can go ahead and disable them by clicking the checkbox under the name of the plugin by where it says enabled in order to remove the checkmark. In this part of the tutorial, we will not be disabling any more plugins in addition to those two virtual reality plugins that we just disabled. By the way, there was nothing special about those two VR plugins that I chose to disable. Virtual reality works absolutely fine with GameLift. So if you're using virtual reality, then feel free to leave those plugins enabled. But this tutorial project specifically does not use virtual reality. And it also probably doesn't use a lot of other plugins that are enabled by default, but I just wanted to show you those two plugins as an example in case you do want to disable more plugins. And lastly, just a note that I'm not 100% sure if disabling plugins improves compile time, so someone please correct me if I am wrong in the comments below. I do know, however, that disabling plugins does decrease the size of the client and server packaged builds because they will, as a result, contain less modules. Now we can close out of this plugins window, and we are going to revisit and edit the main menu UI from the last part of the tutorial. So go to the content browser down here, specifically the UI folder, and then go to the widgets folder and open up the UI_main menu widget. In this widget blueprint, we will be adding some widgets. Let's begin with the button that will be responsible for starting and stopping a matchmaking request. So go to the palette menu on the left side and expand the section labeled common, if it is not already expanded, by clicking on the word common. And under where it says common, click on the button widget, hold your mouse, drag it onto the canvas panel inside the designer view. The canvas panel is a rectangle outlined by dotted lines, and then let go of your mouse to place it onto the canvas panel of the widget blueprint. And since we are going to now have more than one widget inside of this widget blueprint, if you are wondering about the hierarchy order of the widgets, which can be seen inside the hierarchy menu on the left side, although the web browser widget takes up the entire screen, it doesn't really matter whether the new widgets that we are about to add are above or below the web browser widget in terms of hierarchy. The reason is that these new UI elements, including the button, will only be visible after the user has logged in. And after a user has logged in, we are later going to set the visibility of the web browser widget to be hidden. I know that some people may have been wondering about this, since items at the bottom of the hierarchy menu will take precedence when it comes to visibility. So the hierarchy order of the widgets is purely up to you guys. Whatever is easiest to work with. I'm not even following Unreal Engine UMG UI best practices right now, just to keep this tutorial short. So moving on, let's edit the button we just added. So in the details menu on the right side of the screen for this button widget, let's rename this button. So get rid of the default button name in this text box here under where it says details, and we'll replace it with button_matchmaking. And then in the details menu under where it says slot, so in the slot section by where it says anchors, click on the drop down menu that says anchors and hold down Control and Shift and click on this box where there's a little gray square on the bottom right corner of the canvas panel. Because what that does is that it will align and position this button to be in the bottom right corner of the canvas panel. And also, while we're still in the slot section, we're going to modify the position X and position Y values to move this button a little bit up and to the left of the bottom right corner. So let's set the position X value to -50 and the position Y value to -50 as well. And let's also make this button a little bigger. So while we're still in the slot section by where it says size X, let's set that value to 400 to make the button a little wider. And let's set the size Y value to 100 to make the button a little taller. And like I said earlier, all the new UI elements that we are about to add, we are going to set it so that by default they are not visible, because the only way that the user should be able to see these new UI elements is after they have logged in. Because again, once they've logged in, then they should see stuff like player stats and be able to interact with the button that will be able to start and stop a matchmaking request. So in the search bar where it says search details under the button name, let's look up visibility, and you should see a behavior section with a property called visibility. And in this drop down menu where it says visible, just click on that and select hidden, so that by default this button will not be visible. Then let's add some text for this matchmaking button by going back to the palette menu under the comments section, select the text widget and drag it onto the button. Make sure, and you can check this in the hierarchy view, that the button widget is the parent of this new text widget that we just added. Now in the details menu for this text widget, let's clear the search bar by clicking this X button so that we can see all the details. And let's set the name of this widget to text block underscore matchmaking. And now let's set the default text value of this widget by going to the content section by where it says text, and inside this text field where the default value is text block, let's get rid of that default value and let's set that to join game. Press enter to apply those changes. By default, right after the user logs in, the matchmaking button will be used for starting a matchmaking request. But once there is an active matchmaking request involving the user, then the matchmaking button will be used for canceling a matchmaking request, and this text value will change to something indicative of that, like cancel matchmaking for instance. After that, we are going to add some more text block widgets outside of the matchmaking button, solely responsible for conveying different pieces of information to the client. First, let's add a couple of text widgets for the player data, such as the number of wins and losses that a player has. So let's go back to the palette menu and add another text widget to the canvas panel. We're going to call this text block widget text block underscore wins, because this text widget will display the number of wins that a player has. And then in the details menu, under the slot section by where it says anchors, click on the drop down menu that says anchors. And unlike the matchmaking button, we're actually going to update the alignment and position of this text widget to the top left corner of the canvas panel. So hold down Control and Shift and click on this square with a gray square on the top left corner of the canvas panel. And we're going to add some spacing to this button to move it to the right and down a little bit of the top left corner. So by where it says position X in the slot section, let's set a value of 10, and for the position Y we'll set a value of 10 as well. And we're going to make this text widget a little bigger by setting the size X value to 160 to make it a little wider, but we'll keep the default size Y value. And the default text for this text widget, so in the content section by where it says text, let's set the default text to wins : and then we'll press enter to apply the changes. The reason why we're not adding a number after that is because we're going to get the number of wins from an API request to the get player data lambda function. Right now we don't have that, so we're just going to set the default text to wins : and once we get that data, we'll set the text again to include the number of wins that the player has. And by default, let's set the visibility of this widget to be hidden. Next, let's add another text widget for the losses. So go to the palette menu and drag another text widget to the canvas panel. Go back to the details menu and clear out the search bar to see all the details for this new widget. Name this widget text block underscore losses. And like the wins text widget, we're going to anchor this new text widget to the top left corner. So to do that, again, under the slot section by where it says anchors, click on the drop down menu that says anchors, hold down Control and Shift while clicking on this square with a gray square on the top left corner of the canvas panel. And then we're going to add some spacing so that this piece of text is aligned with and below the text that displays the number of wins. So in the slot section in the widget details, set the position X value to 10 and the position Y value to 60. And let's also make this text widget a little wider by setting the size X value to 190. Then set the default text to losses : and press enter to apply the change. Similar to the wins text widget, we will replace this text later with the number of losses after a call to the get player data API endpoint. Lastly, set the default visibility of this widget to hidden. And then let's add another text widget for displaying the client's ping, also known as the network latency between the client and AWS. So let's go back to the palette menu and drag another text widget onto the canvas panel. Go back to the details menu and clear out the search bar to see all the details for this new widget. Name this new widget text block underscore ping. Unlike the wins and losses text block widgets, we are going to anchor this widget to the top right corner of the screen. So under the slot section by where it says anchors, click on the drop down menu, hold down Shift and Control and select the option with a gray square inside the top right corner of a larger square. Next, we will shift this piece of text a little down and to the left of the top right corner by setting the position X value to -10 and the position Y value to +10. And we will make this text widget a little wider by setting the size X value to 200. The default text for this widget will be ping : because we will not be able to calculate the network latency until we start hitting the AWS GameLift service endpoint. Once we do, we will then replace this text value to indicate to include the latency. Unlike the text widgets added so far, we are actually going to set the alignment of the text inside this widget so that the text is aligned to the right. This way the text will never go out of the right side of the screen. By default, the text in a text widget is aligned to the left, so the wins and losses text can never go out of the left side of the screen. So scroll down the details window and find the section labeled appearance. And under where it says appearance, by where it says justification, towards the bottom of the section, select the rightmost option. And lastly, set the default visibility of this widget to hidden. After that, we are going to add one last text widget for this widget blueprint. So go back to the palette menu and drag one more text widget to the canvas panel. Go back to the details menu and clear out the search bar and name this widget text block underscore matchmaking event. So remember those 4 final states that a matchmaking request can end up in that we talked about in an earlier part of the tutorial. In the case that a matchmaking ticket results in a matchmaking succeeded state, the client will then connect to the server and leave this main menu map. But if the ticket ends up in any one of the other 3 states, including matchmaking canceled, failed, or timed out, then what I would like to do is set the text inside this text block widget to let the user know that their matchmaking request did not succeed for whatever reason. Let's anchor this text widget to the center of the screen by clicking the Anchors drop-down menu in the slot section, hold down Shift and Control and select the option with a gray square in the middle of a larger square. And let's make this text widget a lot wider by setting the size X value to 800 and a little taller by setting the size Y value to 50. Then clear out the text value because by default, after a user logs in, there shouldn't be an active matchmaking request for that user yet. Just to repeat, once there is a matchmaking request and it doesn't result in the client connecting to the server, then this text will be populated. Next, let's set the alignment of the text inside this widget so that the text is always placed in the center of the widget by selecting the middle option for the justification property under the appearance section. Also, let's make this text appear a little bigger as well by increasing the font size. So in the same appearance section, click on where it says font, specifically this triangle by where it says font, to expand that section. And under the font section, find where it says size and change the value from 24 or whatever default value is there to 34. And lastly, set the default visibility of this widget to hidden. And once you've done that, let's go ahead and save and compile our widget blueprint by clicking the save and compile buttons on the top left corner. Now, if we go back to the main Unreal Engine editor and open up the main menu map, which in my case is in the third person CPP maps folder. So I'm going to go there and open up the main menu map and play the game. You shouldn't see any of the new widgets that we just made because we set them to be hidden. This is what we want because we only want the user to see these new widgets after successfully signing in. So we can close, or we can stop playing the game now, and we can go back to Visual Studio so that we can edit the main menu widget header in C++ files, starting with the header file. So go to the Solution Explorer and find the main menu widget header file and double click it to open it up. First, let's scroll up to the top of the file and add some for declarations. So after where it says class U web browser, let's add a couple of for declarations for the U button and U text block classes, since those are the type of widgets that we just added. So to do that, type out class U button and then class U text block. And then let's proceed to make some member variables for each of those widgets by scrolling back down and starting with the matchmaking button. So after the web browser member variable, let's type out U property and then U button pointer matchmaking button. And then let's make a member variable for the wins text block. So type out U property and then U text block pointer wins text block. And then let's make a member variable for the losses text block. So type out U property U text block pointer losses text block. And let's make a member variable for the ping text block. So type out U property and then U text block pointer ping text block, and finally one more member variable for the matchmaking event text block. So type out U property U text block pointer matchmaking event text block. Now let's go to the main menu widget C++ file so that we can set these widget references. Find the main menu widget C++ class in the Solution Explorer and open it up. We will be initializing these widget references in the same place we did for the web browser widget member variable, which was in the native construct method. So go there, and right after we initialize the web browser variable, let's set the matchmaking button variable to a pointer to the matchmaking button widget we just made. So to do that, type out matchmaking button equal in parentheses U button pointer, and then get widget from name, and this method will take in one parameter, so we're going to pass in a text object which will take in quotes the name of that widget, which was button underscore matchmaking in that case. And the get widget from name function, it should return a U widget pointer, which is why we wrote U button star here to cast that U widget pointer to a U button pointer. And now let's do the same for all those text block widget references. So for the wins text block, type out wins text block equal in parentheses U text block pointer, and then get widget from name in parentheses text, and then in parentheses again and in quotes text block underscore wins. Now, what we just wrote out for initializing the wins text block member variable is pretty much what we're going to write out for those other three text block member variables. The only thing that changes is 1, the name of the member variable getting initialized, and then 2, the name of the widget being referenced inside this main menu widget class. So let's just take this line and we're going to copy it 3 times. And then let's modify the second one because it's no longer wins text block. We got to initialize the losses text block, and this widget was called text block underscore losses. Next up we have the ping text block. So for this third line here, let's rename that to ping text block instead of wins text block, and that widget was named text block underscore ping. And for the last member variable initialization, it wasn't called wins text block, it was called matchmaking event text block, and the name for that widget was text block underscore matchmaking event. Just going to add some spaces after the U text block pointer cast because I just like how it looks. Alright, so moving on, like I mentioned earlier, we only want these new widgets that we just initialized to appear after a client has successfully logged in. In addition to that, we also want to hide the web browser widget because at that point, the web browser is going to be on a blank screen with some text saying sign in successful. So let's go to the onURL change delegate function for the web browser widget, which was called handle login URL change. And in here, if a sign-in was successful, then we get redirected to the callback URL and we extract the code from the URL's query parameters and then exchange that code for a set of Cognito user pool tokens through an API request. Upon getting a response from the API in the function below called onExchangeCode for tokens response received, let's set the visibility of the various widgets inside this main menu widget class if we successfully retrieved Cognito tokens and store them in our game instance class. So first, let's make the web browser invisible by typing out web browser arrow set visibility, and then in parentheses we'll pass an eSlate visibility :hidden. And then after that, let's set those new widgets that we just made to be visible by typing out, starting with the matchmaking button arrow set visibility in parentheses eSlate visibility :visible. And let's do the exact same thing for the wins text block. We're going to do wins text block set visibility in parentheses eSlate visibility :visible. As I'm typing this out, actually, we can actually do what we did earlier when we initialized some of these new widget references. We can actually take one of these lines and just copy it and then paste it 3 times because it's pretty much the exact same code for setting these widgets to be visible. The only thing that you're really changing is the specific widget reference that you're setting to be visible, or the specific widget that you're setting to be visible. So instead of wins text block for this second line we pasted, or for that first line we pasted, we'll change that to losses text block, and then for the next one we'll change that from wins text block to ping text block, and then the last one we'll change that from wins text block to matchmaking event text block. And you may have noticed some red squiggly lines under these widget variables. That is because I forgot to add a couple of include statements for the uButton and uTextBlock classes. So let's go to the top of the C++ class and add them by typing out #include and then in quotes components /button.h and #include in quotes components /textblock.h. And once you have that typed out, right click your project in the Solution Explorer and select build. Once your project is done compiling, let's go back to the Unreal Engine editor and test out our new changes by playing the game. And just sign in with a valid username and password. So I'm just going to use the Cognito sign-in. You can use any sign-in, whether it's Google or through Cognito. Click on the sign-in button if you use Cognito. And then you should see, upon a successful sign-in, different pieces of text saying wins, losses, and ping, as well as a button that says join game. Now, we will eventually add functionality to this button so that it actually does something. But first, let's focus on populating these different text blocks with actual values. So stop playing the game and let's go back to Visual Studio. Now, the first thing we are going to code is the retrieval of the wins and losses of a user. So when a player logs in and after that player exchanged its code for a set of Cognito user pool tokens, the player should have an access token at its disposal. And this access token will then be passed to a request to the Cognito authorized API endpoint for the getPlayerData Lambda function. If you remember from the last part of the tutorial when we wrote that Lambda function, it calls the Cognito getUser function using the access token in order to get the Cognito sub ID associated with that access token. Then the sub value is used to get an item keyed by that sub value in the player's DynamoDB table. That item will contain the number of wins and losses for that user. So let's go back to the main menu widget header file because we need a response handler function for this getPlayerData API request. So I'm going to add the definition for that handler function at the bottom of the header file here. So I'm going to type out void on getPlayerData response received, and then in parentheses FHTTP request pointer request comma FHTTP response pointer response and bool B was successful. After that, let's go back to the main menu widget C++ class and actually make the request to the API getPlayerData route. So like I just mentioned, we need an access token to even access this Cognito authorized API endpoint. So let's go down to the onExchange code for tokens response receive function, because in this function is where we parse the JSON response from the exchange code for tokens lambda function. And in the case where we do have an access token, we should make an HTTP request with that token. Before we do that, I'm going to take the variables, I'm going to take the parameters that we pass to the setCognitoTokens function and store them in some variables local to this function just to make this long line a little neater. So right above where we call setCognitoTokens inside this if statement, let's type out fstring access token, and we'll set that equal to this first parameter that we pass to setCognitoTokens. So I'm going to cut this value by pressing Ctrl X, and then in here I'm going to type out access token, and then I'm going to go back to that line where we were initializing that local variable, and I'm going to paste that parameter that we just cut into here for the value for the access token local variable, and then I'm going to add a semicolon. And we're going to do basically the same thing for the second and third parameter of the setCognitoTokens function. So next up is the ID token, and we're going to set that equal again to the second parameter passed to this function currently. So we're going to cut that value. We're going to type in ID token, and then for the ID token local variable, we are going to set that to that value. So we're going to paste it in there, and then add a semicolon. And lastly, the refresh token, exact same thing. We're going to set that equal to this third parameter. So cut that value, type in refresh token, then go back to the local variable and paste it in for that variable, and then add a semicolon. Now let's actually make the request. So the format will be quite similar to how we have been doing HTTP requests throughout this tutorial. So down here, let's type out t shared ref, and then in carets I HTTP request, and we'll call this request getPlayerData request, and we'll set that equal to HTTP module arrow create request parentheses. And then let's set the onProcessRequest complete delegate of this request by typing getPlayerData request arrow onProcessRequest complete parentheses dot by new object, and then in parentheses we'll pass in two parameters. The first one is this. Second parameter is the address of the response handler function. So ampersand u main menu widget double colon on getPlayerData response received, and then add a semicolon here at the end. Note that we still have to implement the response handler function, but we will do that very shortly. Let's set the URL of this request by writing getPlayerData request arrow set URL, and then in parentheses, remember all of our API methods are currently stored on one API, so all the routes will be prefixed by the API URL read from that text file we made a while ago. So type in the API URL, and it's going to be the API URL plus the resource name, which in our case is getPlayerData. So add a plus here, and then in quotes /getPlayerData, and add a semicolon here. Next up, this is a GET request, so type out getPlayerData request, arrow set verb, and then in parentheses and in quotes, get. And we will add an authorization header with the access token for this request by typing out get player data request arrow set header, and then in parentheses and in quotes authorization is the first parameter, and the second parameter will be the access token. And then finally, let's send the request by typing out get player data request arrow process request parentheses. After that, we can implement the onGetPlayerData response received function. So let's type out down here void u main menu widget on get player data response received, and then in parentheses fhttp request ptr request comma fhttp response ptr response comma bool b was successful. And then let's add a pair of squiggly brackets. And then here, let's first check if the request made was successful by typing out if in parentheses b was successful. And if it was successful, then let's deserialize the JSON formatted response returned from the API endpoint. To do that, we need to make a JSON object variable. So let's just type out t-shared pointer and then in carets f-JSON object, and we'll call this variable JSON object. And then we will also need to make a JSON reader object. So type out t-shared ref in carets t JSON reader double caret, and then another closing caret. And we'll call this reader object reader. And we'll set that equal to t JSON reader factory carets, and then double colon create, and then in parentheses pass in response arrow get content as string parentheses. Then let's not only deserialize the response using the reader and storing the result into the JSON object variable, but also make sure that the deserialization is successful by writing if in parentheses f the JSON serializer double colon deserialize, and then in parentheses pass in two parameters, first one being the reader and the second one being the JSON object, and then a pair of squiggly brackets. And if we were able to deserialize the response string into a JSON object, then let's check if the response body return had an error field by writing if in parentheses exclamation mark JSON object arrow has field, and then in parentheses and in quotes error, and then a pair of squiggly brackets. So if the response content did not have an error field, then let's assume that the response content has a player item. Similar to how we assume for the exchange code for tokens response that if there is no error field in the response, then that response would contain 3 Cognito user pool tokens, which is pretty much always the case unless there's some very rare situation where the Cognito token endpoint returns something weird. The only situation in which the code would reach this point inside this if statement, if not JSON object has field error, and the response did not contain a player item, is 1, the client was unauthorized when making its request, which we are not going to worry about in this tutorial series because we are going to keep things simple and assume that we always have a valid access token. And 2, for whatever reason is no item in the players table exists for the user currently logged in, and that can be caused by a few very rare scenarios, such as the Cognito trigger not working, or if the item was deleted somehow from the table, for instance. Again, just to keep this tutorial simple, we will not worry about these edge cases. So let's parse the response by first extracting the player data object. So type out t-shared ptr in carets f-JSON object player data, and set that variable equal to JSON object arrow get object field, and in parentheses and in quotes player data. Then from the player data object, let's extract the wins and losses. And since this is an item from the players table in DynamoDB, the wins and losses are technically objects, just like any attribute from an item from a table in DynamoDB. So type out t-shared ptr caret of JSON object wins object and set that equal to player data arrow get object field, and then in parentheses and in quotes, wins. And also type out t shared ptr caret of JSON object losses object, and set that equal to player data arrow get object field in parentheses and in quotes losses. Then extract the actual number of wins and losses from these attribute objects by typing fstring wins equal wins object arrow get string field and in parentheses and in quotes n, and then fstring losses equal losses object arrow get string field in parentheses and in quotes n as well. And now that we actually have the values for the wins and losses, let's set the text in our text widgets to reflect that by typing out wins text block arrow set text and in parentheses f text double colon from string in parentheses and in quotes wins colon space plus wins. And we'll do the exact same thing for the losses text block. So type out losses text block arrow set text and then in parentheses f text double colon from string in parentheses and in quotes losses colon space plus losses. And I know earlier in this video we set the new widgets to be visible and the web browser widget to be hidden upon a user successfully signing in and getting a set of Cognito user pool tokens, but I want to change it so that that only happens when the request to the get player data function finishes. Because there's no point in displaying the wins and losses text without the actual number of wins and losses, let's go back up to the onExchange code for tokens response receive function. Highlight with your mouse all of the widget set visibility code and cut this snippet of code by pressing Ctrl X, and then scroll back down to the last if statement in the onGetPlayerDataResponseReceive function and just paste that snippet of code in here. And once all that is done, let's right click our project in the Solution Explorer and build. And once your project has finished compiling, let's go back to the Unreal Engine editor and play our game. Sign in with a valid username and password. And once you sign in this time, you should notice now that there are numbers displayed along with the wins and losses pieces of text. And the numbers make sense, 0 wins and 0 losses, since I've signed into a user that has not played a game yet. Now we have to get this ping value so that we can populate this ping text block. So let's stop playing this game and go back to Visual Studio. Now, because I plan to have the ping value persist on the client even when the client leaves the main menu map to go to the server map and back, we are going to store the player's network latency on the game instance class. So find the GameLiftTutorial game instance header file and open it up. And the reason I want it to persist is that we will also continue to display this ping value when the client connects to the server. So the first thing we're going to do is override the game instance init method. So type out underneath the shutdown method virtual void init parentheses override. And the reason we are doing this is that we will use the init method to set a timer function that periodically calls the AWS GameLift service endpoint. In order to do that, we also need a timer handle. So type out underneath the retrieve new tokens handle uProperty parentheses f timer handle get response time handle. And as we call the service endpoint multiple times, we will be storing the response times in a t double linked list variable. So let's type out t double linked list in carets float, and we'll call this variable player latencies. This variable type is analogous to the doubly linked list data structure, which is advantageous because it gives us access to both the head and the tail elements of a list of floats. Head and tail just means first and last elements respectively. The reason that we are keeping track of multiple response time values is that normally when you calculate the network latency, you usually use more than one value to do so. For example, the Windows built-in ping command uses 4 response time values by default. In this tutorial, we will do the same. And just to quickly show you guys what I'm talking about, I'm going to open up command prompt and actually run the ping command by typing ping space and then any website. So I'll do www.google.com and press enter. And you will notice that the ping command will send the request to the URL that you specified 4 times. And it gives you statistics on those requests. Since this was just for show, let me close out of this. And another reason that we are using a doubly linked list is that we can constantly keep track of only the last 4 player latency values, making this variable synonymous to a queue data structure, following the first in first out principle. So when the list gets full and we have to add a new float value, we remove the oldest float value to make room for that new value. Think of it like a line into an amusement park attraction. The first people in line are the first people to get out of the line and into the ride. Although Unreal Engine already has a couple of built-in queue variable types, we are not using any of those because those built-in queues are not iterable. There is a caveat to that though, meaning that the built-in queues are technically iterable, but while iterating through a queue, you have to remove all the values inside the queue to do so. And we need a data structure that we can iterate through in order to calculate the average player latency for a more accurate measure on the network latency, which is why we ended up with the T double link list variable. Alright, moving on, let's make another member variable for this game instance class. This one will be private, so underneath the API URL, I'm going to type out uProperty, parentheses, and this variable will be of type fstring, and it will contain the region code from that text file we made earlier. So this variable will be called region code. And lastly, let's make a couple of functions. The first one will be the function passed to a call of setTimer, and this function will be responsible for hitting that AWS service endpoint. So let's type out under this retrieve new tokens function, ufunction, parentheses, void get response time. And another function we need is a response handler for requests made to that AWS service endpoint, because after the request is finished, we need to get the time between when the request occurred and when we got a response back so that we can update our player latency variable. So underneath this onRetrieveNewTokens response receive function, type out void on get response time response received, in parentheses fhttp request ptr request, comma fhttp response ptr response, comma bool b was successful. Okay, now let's go to the GameLift tutorial game instance C++ class so that we can start implementing these functions. But first, let's read in the region code from the region code text file. So in the constructor, let's type out region code equal text reader arrow read file, and then in parentheses and in quotes the path of the region code text file relative to the content folder. So that's going to be urls/region code.txt. Now let's implement the init function under the shutdown method by writing void uGameLiftTutorial game instance init parentheses and then squiggly brackets. For those wondering what the init function is used for, it is basically a function that gives custom game instance classes an opportunity to set up what it needs. In our case, what the game instance needs is a timer function, and the first thing we're going to do in here is call the superclasses version of init by typing out super init parentheses. And let's set up the get response time function to be called every second. So let's type out get world parentheses arrow get timer manager parentheses dot set timer, and this function will take in 6 parameters. So the first one will be a timer handle variable. So we made one earlier that was called get response timer or get response time handle, comma, and then the second parameter is going to be this, comma, and then the third parameter is going to be the address of the function to be invoked. So in our case, it's going to be ampersand u GameLift tutorial game instance :get response time, comma. And then the fourth parameter is going to be a float denoting how often you want this function to be called. So we're going to have this function called every second, so we're going to type out 1.0f, comma, and then the next parameter is going to be true. So last time we called the setTimer function, we had this as false because there may be times where we don't want to necessarily call a function every X seconds. Now we do want a function to be called every X number of seconds. In this case, because our last parameter was 1, we want getResponseTime to be called every second. And then another comma, the last and sixth parameter is going to be like it was before, the initial delay for when the function is called for the first time. So we're just going to set that to be 1.0f. So in 1 second, this function getResponseTime will be called, and from there on out, it will continue to be called every second. But we actually have to implement this getResponseTime function. So scroll down and let's type out void u GameLift tutorial game instance :getResponseTime, parentheses, and then a pair of squiggly brackets. And in here we are going to make an HTTP request to the AWS GameLift service endpoint. So to do that, let's make an HTTP request object by typing t shared ref in carets I HTTP request get response time request, and set that equal to HTTP module arrow create request parentheses. Then set the onProcess request complete delegate of the request to our response handler function that we defined earlier by typing out get response time request arrow onProcess request complete parentheses .bind u object, and then in parentheses this function will take in 2 parameters. So the first one will be this, and then the second parameter will be the address of the handler function. So let's type in ampersand u GameLift tutorial game instance :on get response time response received, and then add a semicolon at the end. And for the URL of this request, let's type out get response time request arrow set URL, and then in parentheses, like I mentioned earlier, the URL of the endpoint follows a specific format. It goes in quotes https://GameLift dot, where GameLift can be swapped with any AWS service, then plus the region code that you are using, and plus in quotes .amazonaws.com. And this is a GET request, so type get response time request arrow set verb in parentheses and in quotes get. And finally, let's process the request by typing get response time request arrow process request parentheses. And the last thing we have to implement is the on get response time response received function. So let's type out void u GameLift tutorial game instance :on get response time response received, and then in parentheses f http request ptr request comma f http response ptr response comma bool b was successful, and then a pair of squiggly brackets. And at the time of calling this response handler function, since we are going to be adding a float value to the player latency's double linked list variable, if there are already 4 floats in the list, then it is considered full like how we mentioned earlier. In this case, we are still going to add the float while making the list mimic a queue by removing the head value from the list, which represents the first value in first in first out, aka the value currently in the list that has been there for the longest period of time. So let's first check if player latencies is quote unquote full by typing out if in parentheses player latencies dot num parentheses greater than or equal to 4, and then squiggly brackets. If it is, then let's remove the head of the list by typing out player latencies dot remove node in parentheses player latencies dot get head parentheses. And then let's get the amount of time it took for the client to get a response back from the AWS service endpoint by typing out float response time and set that equal to request arrow get elapsed time parentheses, which returns a float value representing the elapsed time between sending the request and receiving a response in seconds. So let's multiply this value by 1000 to get the time in milliseconds. And just for testing purposes to make sure that the new game instance code that we just wrote works, let's add a log statement showing the response time by typing out UE_log in parentheses log temp, comma, warning, comma, text, in parentheses and in quotes, response time in milliseconds, colon, %s. And for the string placeholder, that will be the response time, which we have to convert to a string by writing comma and then star f string double colon sanitize float in parentheses response time. And lastly, we will add the response time to our player latencies variable, specifically to the end of the list at the tail by writing player latencies.add tail and then in parentheses response time. This is again to make sure that the list mimics a queue. And after that, we can go ahead and right click our project in the Solution Explorer and build. Once your project is finished compiling, let's go back to the Unreal Engine editor and start up your game. Then let's go down here specifically to the output log section. And you should see a bunch of log statements saying response time in milliseconds and then the amount of time in milliseconds that it took to get a response from the AWS GameLift service endpoint. Seems that everything is working here because again we see these log statements. So now what we have to do is populate that ping text block with the average player latency from the last 4 recorded response time values. In my case, it seems like the average response time is about like, I guess 25 to 30-ish seconds. And it's important to note that the reason why we had that queue logic is that notice how these log statements go on forever because we are constantly calling the get response time function. If we didn't have that remove head and add tail logic, then our list would just constantly grow forever with no limit, looking like this huge list of log statements, which is not what we want. So let's move on, stop playing the game, go back to Visual Studio, and like I just said, that log statement is just for testing. So since we made sure that everything worked, now let's just comment it out. Now it's time to go back to the main menu widget header file, and in the main menu widget we're going to do something similar to what we did in the game instance class, in the sense that we're going to set a timer function to be called every second. And this function will be responsible for calculating the average player latency and adding that to the text inside the ping text block. So for that, we first need a timer handle variable, so let's make this public, and I'm going to type out uProperty parentheses f timer handle, and let's call this variable set average player latency handle. And then let's define a member variable to keep track of the average player latency. So scroll down and under where it says uTextBlock matchmaking event text block, let's type uProperty parentheses, and we'll make this property of type float, and we'll call it average player latency. And we will also need a function for that timer, so let's type under this handle login URL change function uFunction parentheses void set average player latency parentheses. Okay, now let's go back to the main menu widget C++ class, And before we implement that new function, let's do a couple things. So scroll back up, and first in the constructor, let's set a default value for the average player latency. So type out average player latency equal, and we'll just make it 60. Next, in the native construct method, a little bit down below, let's call setTimer to call the setAveragePlayerLatency function every second, similar to how we did it for another function in the GameInstance class. So under where we initialize the matchmaking event text block, let's type out get world parentheses arrow get timer manager parentheses dot set timer. Then in parentheses, we're going to pass in 6 parameters. First one will be set average player latency handle. That's that timer handle member variable that we defined earlier. Next parameter is this. Next parameter after that is ampersand u main menu widget : set average player latency. Again, the average of the function that we want to invoke every second in our case. And then the next parameter is 1.0f because again we want to call this function every second. And the next parameter after that is true because we want to repeatedly call this function. And then the last parameter is also 1.0f because that is the initial delay before we call the function for the very first time. And now let's actually write the set average player latency function. So scroll down and let's type out void u main menu widget : set average player latency parentheses and then squiggly brackets, and in here we have to get the player latency values from the game instance. We first need the game instance, so type out u game instance pointer, call this game instance, and we'll set this equal to get game instance parentheses. And let's just do a quick null pointer check on the game instance by typing if in parentheses game instance not equal null pointer, and then squiggly brackets. Then we have to cast the game instance to our custom game instance, so write u GameLiftTutorial game instance pointer, and we'll call this variable GameLiftTutorial game instance, and we'll set that equal to cast in carets u GameLiftTutorial game instance, and then in parentheses we'll pass in the game instance. And let's do a null pointer check on that as well by typing if in parentheses GameLiftTutorial game instance not equal null pointer squiggly brackets. And if we have made it this far, then we can get the player latencies and calculate the average of the last 4 response times. So first, let's make a local variable to keep track of the sum of the player latencies. So let's type out float total player latency, and we'll set that equal to 0 by default. Then let's iterate through the player latencies linked list variable in the game instance, and as we iterate through each float value, we will add it to the total player latency variable. So let's type out for in parentheses float player latency : GameLiftTutorial game instance arrow player latencies, and then squiggly brackets inside this loop. Let's add each player latency value to the total player latency variable. So let's type out total player latency plus equal player latency. So if you're not familiar with the plus equal operation, all it does is it takes the current value of total player latency, adds that with the player latency value that we are iterating on, and then set the total player latency variable to that new sum value. And after iterating through the player latencies, let's calculate and set the average latency. Before that, let's first check if we even iterated on any player latencies by writing if in parentheses total player latency greater than 0, and then squiggly brackets. Because if we iterated on at least one latency value, then the total should be greater than 0. This if check is usually most of the times going to evaluate to true, but it's just a safe check to have. So in here, let's set average player latency equal to total player latency divided by the total number of float values in the player latencies linked list, which is usually 4, but again, rarely it is not. So we can get the number of values from the list by typing out GameLift tutorial game instance arrow player latencies dot num parentheses. And finally, let's set the text of the ping text block to include this average latency value. First, let's make the string value for the text block, so type out fstring, and we'll call this variable ping string, and we'll set it equal to, in quotes, ping colon space plus fstring double colon from int, in parentheses fmath double colon round to int, in parentheses average player latency. And then at the end of the string, we'll add plus, in quotes, ms, and the ms stands for milliseconds. So the reason why we call the fmath round to int function on the average player latency is that the average player latency is a float value, and because it's a float value, you can have a lot of digits to the right of the decimal point. And since we're displaying this text for the user to see, we don't want to crowd the screen up with a bunch of unnecessary digits. So the fmath round to int function basically will just round a float to the nearest integer. Basic math rules, for example, if we have anything from 0.5 or greater up to 1, then the float will round up to 1. But if it's anything less than 0.5 and greater than or equal to 0, then the float will round down to 0. And then we need to call fstring from int, because we have to convert the integer resulting from the round to int function to a string. And then let's actually set the text inside the ping text block by typing out ping text block arrow set text, and in parentheses we'll pass in ftext double colon from string, and then in parentheses ping string, because the set text function takes in a text value. So you have to convert the fstring value to a ftext value. And then once you've done that, right click on your project and build. And once your project has finished compiling, let's go back to the Unreal Engine editor to test our changes. So play the game and let's log in with a valid username and password. So I'm just going to use the same FlopRam account that I've always been using. And once you sign in, you should now see a value by where it says ping, and notice that this value may be constantly changing, which is normal because we are constantly recalculating the average player latency so that it is as accurate and up to date as possible. Now what's left to code is writing the main functionality of the matchmaking button, which will eventually allow us to start and stop matchmaking requests. So let's stop playing the game and go back to Visual Studio. And let's go back to the main menu widget header file. And we're going to define a new function to be invoked for when we click on the matchmaking button. But before that, I want to define another member variable for this widget. So under the average player latency, let's type out u property parentheses bool searching for game. And the point of this variable is to help us keep track of the state in which the client is at with regards to whether or not they currently have an active matchmaking request going on. And depending on the value of this Boolean property, the matchmaking button will serve different purposes. For example, when there is no active matchmaking request and the user is not currently searching for a game, the matchmaking button will be responsible for starting a matchmaking request. But if there is an active matchmaking request and the user is currently searching for a game, then the matchmaking button will be responsible for stopping a matchmaking request. It's generally not recommended to keep track of state like this in a widget class, but just to save time in this tutorial, we will go against best practices. And then next up is the function. So at the bottom here under the set average player latency function, let's type out u function parentheses and then void on matchmaking button clicked and then parentheses. Now let's go to the main menu widget C++ class and implement this function as well as connect it to the matchmaking button. So first we're going to initialize the searching for game variable. So go to the constructor and let's set searching for game equal to a default value of false. Then let's go to the native construct method and bind the new onMatchmakingButtonClicked function that we just defined to the matchmakingButtons onClick delegate, so that every time the user clicks on the button, that function will get called. So let's type out fscript_delegate, and we'll call this variable matchmakingDelegate, and then we will set the u function of this matchmakingDelegate by typing out matchmakingDelegate.bind u function, and we'll pass in two parameters to this bind u function. The first one will be this, and the second one will be, in quotes, the name of the function we want to invoke. So it's going to be onMatchmakingButtonClicked in our case. And then lastly, we're going to set the onClick delegate of the button by typing out matchmakingButton arrow onClicked.add, and then in parentheses pass in the matchmaking delegate. And we still have to actually implement that onMatchmakingButtonClicked function, so let's scroll down and type out void uMainMenuWidget onMatchmakingButtonClicked parentheses and then squiggly brackets. And for now, we are just going to write a small amount of code just to test that we set up the matchmaking buttons on click delegate properly so that this function will get called. With that said, let's make this function apply some minor UI changes, depending on the state of the client with regards to whether or not they are currently searching for a game, like how I mentioned earlier. So again, if the client is currently searching for a game, and let's add a check for that by typing if in parentheses searching for game, and then squiggly brackets. First, this button will always change the state upon a click. So if searching for game is true and the client clicks the button, then let's set searching for game equal to false. Assuming at this point that the client already has an active matchmaking request going on and clicking the button during that state is meant to cancel that matchmaking request, let's set the text of the button to say join game, because the next time they click the matchmaking button, it should be meant for starting a matchmaking request. Because we are going to assume for now that after clicking this button, while the client is actively looking for a match, their current matchmaking ticket will be canceled. So to change the text of the button, let's get that text block widget, which is the only child of the button widget. So to get the child, type out u text block pointer, and we'll call this variable button text block, and we'll set it equal to, in parentheses, u text block pointer, and then we're going to cast matchmaking button arrow get child, in parentheses 0. And the get child at 0 just indicates that we're getting the first child of the matchmaking button. And let's set the text of that text block by typing button text block arrow set text, in parentheses we're going to pass an f text double colon from string, in parentheses and in quotes join game. And let's also clear the text inside the matchmaking event text block, because if the user wants to cancel the request, then the result of clicking this button will be that there is no active matchmaking request, just like when the user first sees the main menu map after successfully logging in, where there was no text inside this text block. So let's type out matchmaking event text block arrow set text, in parentheses f text double colon from string, in parentheses just a pair of quotes with nothing inside of them, not even a space. And if searching for game is false, so in the else case, since what happens here is sort of the opposite of what happens in the body of the if statement above, let's just copy that body of code and paste it inside the body of the else statement. And then we'll change a few things. So first we'll set searching for game to true instead of false. And if searching for game was originally false, then the client is not looking for a match currently, and they are clicking on the button expecting to start a matchmaking request. With that said, let's change some UI elements to make it look like the next time they click the button that it will cancel a matchmaking request. So let's change the button text to say cancel matchmaking instead of join game. And we'll have the matchmaking event text block say currently looking for a match. And then after that, let's compile our project by right-clicking it and selecting build. Okay, once that's done, let's go back to the Unreal Engine editor so that we can test this new minor button functionality that we just added. So play the game and let's log in with a valid username and password. So we'll just use the same account that I've been using throughout this tutorial. For now, try to stick with one account. I know I probably should have said that earlier, but if we click on this join game button now, you should see a couple of things change. Not only did the button text change from join game to cancel matchmaking, but so did the matchmaking event text in the middle of the screen. And if we click the button again, we should see the button text change back to join game and the matchmaking event text get cleared out. Of course, we can keep on clicking this button and it will keep switching back and forth between the two searching for game states, true and false. Now, this was just for testing because now we need to actually perform HTTP requests to the REST API so that we can start and stop matchmaking requests. So stop playing the game and let's go back to Visual Studio. Actually, before we start coding those HTTP requests, I want to do something that just caught my attention. So in most of our HTTP response handlers, we add a general if check to make sure that the response body as a JSON object does not have an error field. But I think it would be better to instead replace that if check with another if check that made sure that the JSON object had the fields that we were looking for. So for example, in this one, in this onGetPlayerData response receive function, we parse out a field called player data. Because assuming everything goes well, the getPlayerData lambda function should return a response body with a player data field in it. And then API Gateway will send that back to our Unreal Engine client. So let's remove the exclamation mark at the beginning of this if check. And then let's replace this error string with player data. With that change, we are now checking if the response body has a field called player data. And the reason why I decided to change this is that I just realized that there may be circumstances that I am unaware of that can cause an HTTP request to go wrong or the response sent back to go wrong. And even if the JSON object doesn't have an error field, like we mentioned before, it could also have an unauthorized field instead of an error field. So on the API Gateway side, again, we have a cognito authorizer. Even though I said that in this tutorial, we are assuming that our access token will always be valid. There may be other reasons that API Gateway throws an error response, like something like an unauthorized message. For example, if throttling limits have been reached, like the API Gateway endpoints are getting hit way too often. In that case, before, since the only check we had is we only checked if there was no error field, it would actually still go into this if statement. And the weird thing is, so these get object field and get string field methods, so they don't necessarily crash the program, which sounds good, but what they end up doing is if they can't find the object field or the string field in whatever you're looking in, then it will simply just populate the variable that you set the value to either null or some empty string. And that's not really what we want. I'd rather just not have it do it at all if the field in the response that we're looking for doesn't exist. So let's actually do this for every single if has field error check in the code so far. So we have another response handler function where we do this, actually in this class called onExchangeCode for tokens response received. So in this if JSON object has field error check, let's once again get rid of the exclamation point and we'll get rid of the error string and replace that with access underscore token, because one of the fields we're looking for in the response body directly is the access token. And let's do the exact same thing for the other two tokens we're looking for. So double ampersand JSON object, arrow has a field in parentheses and in quotes ID underscore token. And let's add a closing parentheses and another pair of ampersands, and then JSON object arrow has field, and then in parentheses and in quotes refresh underscore token. And We also have to do this error check. We also have to replace this error check in a response handler in the game instance class. So go to the game instance C++ class, and specifically the onRetrieveNewTokens response receive function, and replace that if JSON object does not has field error with, again, get rid of the exclamation point and replace this error string with access token. And then let's add double ampersand JSON object arrow has field in parentheses and in quotes ID token, because again, we are expecting a access token field and a ID token field in the body of the response return. Notice that I don't have a has field check on the refresh token because that is the only token that we do not replace when retrieving new tokens. And once you've done all that, let's actually right click our project and build. And then let's just quickly go back to the Unreal Engine editor and test everything to make sure that everything still works as if nothing really changed. So if I sign in here, we should see a black screen with the number of wins and losses, as well as the ping, as well as the join game button. So it seems like everything works, so we can stop playing the game. The only thing that I couldn't test directly was the refresh token, or retrieving new tokens, since the interval right now is every 55 minutes. But if you do want to actually test it again, I don't think it's really necessary. I think we can kind of just go on our gut instinct and say that the onRetrieveNewTokens response receive function still works. But if you do want to change it, if you go to the setCognitoTokens function, and if you look at the last variable right now, this is 3300, but if you just want to make sure everything still works, like if you want to be extra cautious, you can make this like a super low variable, like 10 or something, and then uncomment one of these log statements. Actually, I wouldn't mind doing that right now. Let's just change this very quickly to like 10, and then we will uncomment the access token log statement. We'll right click our project and build. And if everything still works, which it should because we didn't really make any major changes, then we should just constantly see a new access token, because we're constantly calling the retrieve new tokens lambda function, and as a result we are constantly retrieving new access tokens. So now if we go back to the Unreal Engine editor, and let's make sure we have the output log section selected. So if we sign in, and let's sign in. So as you can see, we see one access token, and in a very short amount of time, so about 10 seconds, we'll see another access token. And again, assuming everything worked, then the new access token we see should be slightly different, because again, it's a new token generated using the refresh token. And I know it's hard to see, but they are different. And as you can see, there's another access token which is also different. So that is working. Let's stop playing the game. Let's go back to Visual Studio. Let's just undo those changes. So comment that log statement back and change that last parameter from 10 seconds back to 3300 seconds, aka 55 minutes. And let's build the project again. Okay, now moving on, while we are still in the GameLift tutorial game instance class, let's actually go to the header file for this game instance and add a new property for the matchmaking ticket ID. So type out under where it says uProperty string refresh token, uProperty parentheses f-string matchmaking ticket ID. And the reason I want to make this matchmaking ticket ID in the game instance as opposed to the main menu widget is that, let's say the user starts a matchmaking request, and while the ticket is still in matchmaking searching status, the user quits the game. Now in that case, I would like to make an HTTP request to the stop matchmaking endpoint in the game instance's shutdown method. Now let's go to the main menu widget header file. And then here, let's define two response handler functions, one for the start matchmaking API method and another for the stop matchmaking API method. So let's start with start matchmaking by typing out void on start matchmaking response receive. And then in parentheses, just like the other two response handler functions we defined, it will be the exact same 3 parameters. So just take one of these response handler function definitions, copy their parameters, and just paste them here in these parentheses. And then let's write another one for stop matchmaking. So type out void on stop matchmaking, response received, and then in parentheses, same thing. It's going to be the same 3 parameters as we used for the other response handler definition. So just copy the parameters from one of the other functions and then paste them in here. And I also forgot, let's make another member variable for the region code, because we will need that later for when we make a matchmaking request. So let's go up here, and after the callback URL, let's type out uProperty parentheses of string region code. Okay, now let's go back to the main menu widget C++ class, and the first thing we will do is set the region code variable to the text value inside the region code text file. So let's go to the constructor, and up here let's write region code equal text reader arrow read file, and then in parentheses and in quotes url slash region code.txt. Now let's go to the on matchmaking button clicked function and make that a little more sophisticated. So the first thing we are going to do in this method is actually disable the button in order to prevent quote-unquote double clicking. Because HTTP requests are asynchronous, meaning that this onClick function for the button will not wait until the HTTP request is finished. So we don't want users to accidentally click the button multiple times and send multiple HTTP requests to the API as a result. So let's type out matchmaking button arrow set enabled, and then in parentheses we'll pass in false. And we will re-enable this button after we get a response back from whatever API endpoint we hit. Then let's define some local variables that we will use to store values from the game instance. So the first one will be of type fstring and called access token. And the second one will be of type fstring and called matchmaking ticket ID. Now we actually need to retrieve the game instance, so to do that, type out uGameInstance pointer game instance and set that equal to get game instance parentheses. And let's do a null pointer check on the game instance, just like we've been doing it before. And then we have to cast this game instance to our custom game instance. So type out GameLiftTutorial game instance pointer GameLiftTutorial game instance, and set that equal to cast in carets GameLiftTutorial game instance, and then in parentheses pass in the game instance. And we will do a null pointer check on that as well, just like we've always been doing. And then assuming nothing is null, then let's get the access token so that we have access to Cognito authorized API resources by typing out access token equals GameLiftTutorial game instance arrow access token. And let's get the matchmaking ticket ID for when we want to cancel a matchmaking request by typing out matchmaking ticket ID equals GameLiftTutorial game instance arrow matchmaking ticket ID. And then let's go into the body of if searching for game and add on to this by actually making an HTTP request inside of here to the stop matchmaking API method, so that if the client is currently searching for a game and they want to cancel their matchmaking ticket, then they can click the button and the code inside this if statement should perform that function. So let's first check if we were able to get the access token and matchmaking ticket ID by typing out if in parentheses access token dot len parentheses greater than 0 double ampersand matchmaking ticket ID dot len parentheses greater than 0 squiggly brackets. Since f-string variables by default are initialized to empty strings, the length of those local variables we made earlier have to be greater than 0 if we got the values from the game instance. Next, let's make the request body JSON object by typing t shared ptr and then in carets f.json object, and we'll call this variable request obj, and we'll set it equal to make shareable in parentheses new f.json object. And let's add a field to this JSON object for the ticket ID by typing out request obj arrow set string field, and then in parentheses, this function will take in two parameters. The first one will be the name of the field, so in quotes let's write out ticket ID, and then the second parameter will be the actual value, so in our case it will be the matchmaking ticket ID. And then in order to serialize this JSON object into a JSON formatted string to pass to the request, we need a couple of things. One is a local fstring variable, so type out fstring request body, and another thing we need is a tJSON writer instance, so type out t shared ref and then in carets tJSON writer with another set of sideway carets, and we'll call this variable writer, and we'll set it equal to tJSON writer factory, and then sideway carets double colon create, and in parentheses pass in ampersand request body. Now let's serialize the request body object into a JSON formatted string and check if that serialization went okay by typing out if in parentheses f JSON serializer double colon serialize, and then in parentheses pass in request obj.toShared ref parentheses comma writer, and then a pair of squiggly brackets. And if the serialization is successful, then let's make an HTTP request to the stop matchmaking endpoint by typing out t shared ref carets I HTTP request. Call this request stop matchmaking request, and we will set it equal to HTTP module arrow create request. And let's set the response handler function for this request by writing stop matchmaking request arrow on process request complete parentheses dot find new object, and then in parentheses pass in this comma ampersand new main menu widget double colon on stop matchmaking response received. Now, I know that the onStop matchmaking response receive function isn't implemented yet, but we will get there shortly. And let's set the URL of this request by typing stop matchmaking request arrow set URL and parentheses. The URL is similar to all the other API endpoints we have hit before. They are all prefixed by the API URL, and after that is the resource name, which in this case is in quotes /stop matchmaking. And this is a post request, so let's type out stop matchmaking request arrow set verb, and then in parentheses and in quotes post. Cool. And we need to add a couple of headers, so type out stop matchmaking request arrow set header, and then in parentheses the name of this header will be content-type, and the value will be in quotes application/JSON. This header again is for encoding the request body in JSON. And then let's also type out stop matchmaking request arrow set header, and then in parentheses the name of this header will be authorization, and then the value will be the access token. This header again is for bypassing the Cognito authorizer. And let's add the request body by typing out stop matchmaking request arrow set content as string, and then in parentheses we'll pass in the request body. And then finally let's actually send the request by typing out stop matchmaking request arrow process request. And in the cases for whatever reason that the HTTP request cannot be made, which can either be there was no access token nor matchmaking ticket ID, or the JSON serialization failed, which by the way both cases are extremely rare and I don't expect them to ever happen, but it can't hurt to write some else statements to cover these scenarios. So let's write after this else squiggly brackets, make sure it's aligned with the fjson serialization if statement. And let's copy these 3 lines of code down here where we modified 2 pieces of text and paste them inside this else block. And in addition to that, let's also re-enable the matchmaking button. Since we were never able to make an HTTP request if we reach this block of code, there's nothing to wait on. So type out matchmaking button arrow set is enabled, and then in parentheses true. And you may be wondering, why are we doing this? I just thought that it would be good to give the user the illusion that their matchmaking request was indeed canceled, even if something went wrong while trying to do so. It's not necessarily the greatest idea, but for this tutorial, I just want to keep things simple. So in addition to this, let's add another else statement for the if check on the access token and matchmaking ticket. So else, and then squiggly brackets, and let's copy these 4 lines of code from right above and paste them in this new else block. And because now we have these 4 lines of code in each of these else blocks, we don't need these 3 lines of code outside of those if statements, so you can get rid of those. And just wanted to make a couple more points about giving the user the illusion that their matchmaking requests will always be canceled. Notice up here how we set searching for game equal to false, even before doing anything. We won't be doing the same thing for when the user wants to start a matchmaking request, because in my opinion, the client should try to let the user know if something went wrong with making a new matchmaking request. Because with canceling a matchmaking request, even if the user does not know that something went wrong, they can always just start a new matchmaking request. Whereas with creating a matchmaking request, if the user does not know that something went wrong and believes that they are in queue for a new match, then the user will just wait and be confused because no updates are coming in if there is no existing matchmaking ticket. So we will eventually remove the code in this bottommost else block, but not just yet. First, let's make the HTTP request to the Start Matchmaking API endpoint, which will look very similar to how we did it for Stop Matchmaking. So let's copy the code from above in the if searching for game block up to right before and not including searching for game equal false. So just copy that, and then in the bottommost else block, right before we set searching for game equal to true, just paste it in there. And of course, we are going to be changing a lot of things, starting with the top. In this if check on the access token and matchmaking ticket ID length, we can get rid of the part of the if statement that checks the length of the matchmaking ticket ID. Because when making a matchmaking request, we are not sending a ticket ID. Rather, we are expecting to get one back in the response. However, we are still going to be sending a request body, just not one with a ticket ID. So let's get rid of these 2 lines of code right after this if statement. And remember that code we wrote earlier to get the average player latency. This is where that comes into play, because like we mentioned earlier in the tutorial series, GameLift has a backend process called Fleet IQ that uses player latency data from multiple regions to help determine which fleet to place a match on to best minimize the average player latency across all players. Now in this tutorial, we are only getting the average latency from one region to keep things simple, so it won't be obvious of what Fleet IQ is doing in this tutorial, but after making this request body JSON object, you should have an idea of how to send latency data for more than one AWS region to a call of GameLift Start Matchmaking. So type out t shared ref in carets of JSON object. We'll call this latency map obj, and we'll set it equal to make shareable in parentheses new f JSON object. And note that this latency map object variable is not going to be the main request body object. It's actually going to be a field in the request body. But before we get to that, let's set a number field in this JSON object by typing out latency map obj arrow set number field. Then in parentheses, the name of this field will be the region code. And then the actual value for this field will be the average player latency. And just keep in mind, when you're setting latency data for multiple regions, you add on more number fields onto the same latency map JSON object, and instead of just having one number field with one region code and one value associated to that region code, you'll have multiple number fields, each with their own region code, their own unique region code, and each of those fields will have a different value. So after that, let's make the actual request body that we're going to send, the request body object, by typing out t-shared ref in carets fjson object, and then we'll call this request obj, and we'll set it equal to make shareable in parentheses new fjson object. And like I said earlier, we're going to set an object field for this request object. So type out request obj arrow set object field, and then in parentheses the name of this field will be latency map, and the value for this object field will be the latency map object that we just made. And then for the HTTP request, we have to make a lot of changes. First, let's change the name of the request from stop matchmaking request to start matchmaking request. Let's just copy that name and replace it for all the time stop matchmaking request appears in this if block. So I'm just gonna paste it for all of these. And then let's change the response handler function for this request from on stop matchmaking response received to on start matchmaking response received. Again, like I said earlier, we have to implement this function, which we will do very shortly. And let's change the resource in the URL of this request from stop matchmaking to start matchmaking. And then in these else blocks, let's get rid of everything but matchmaking button arrow set enabled. Set is enabled true. So we'll do it for both of these else blocks. And again, the reason we're doing this is, unlike for stopping a matchmaking request, we want to try to avoid letting the user believe that they are in queue for a match if something went wrong with making a matchmaking request. And if something did go wrong with making a matchmaking request, we'll just set the matchmaking button to enabled again. But we won't set any text to, again, give them the illusion that they're in queue for a match. So they should know, okay, something probably went wrong because they clicked the button. Maybe in a very, very, very rare scenario, either the access token doesn't exist or the JSON serialization didn't work. In these very rare scenarios, the matchmaking button will not change its text, and neither will the matchmaking event text block text change as well, but the button will be re-enabled again, so if they want to, they can try to make a matchmaking request again. And as for these 4 lines of code at the bottom here, just leave them alone for now. We will get rid of them later. Also, before we move on, I just realized I made a very big typo, so go up here to where we set the fjson object variable for the request object. This should not be t-shared ref, it should actually be t-shared ptr, kind of like how we did earlier for the stop matchmaking request. Notice how the request object was of type t-shared ptr fjson object rather than t-shared ref fjson object. The latency map object, though, that should definitely be of type t-shared ref fjson object. So now let's actually start implementing the response handler function, starting with on start matchmaking response received. So type out void uNameMenu widget ; on start matchmaking response received, and in parentheses pass in the 3 parameters of HTTP request ptr request, and then comma FHTTP response ptr response, and then comma bool b was successful, and then a pair of squiggly brackets. And just to save some time in these tutorials, let's just copy this method implementation and then just paste it right below it, because it's pretty much the exact same thing for on stop matchmaking response received in terms of the method signature, since they both take in the same 3 parameters. So just replace the start and on start matchmaking response received for this function to stop. Back to the on start matchmaking response received function. Let's check if the request was successful. by typing if B was successful, and then squiggly brackets, and if it was, let's deserialize the JSON formatted response body into a JSON object by making a JSON object variable and a tJSON reader variable. So type out t shared ptr, and then in carets of JSON object, call it JSON object, and then t shared ref in carets tJSON reader carets, and then we'll call that reader, and we'll set it equal to tJSON reader factory carets double colon create, and then we'll pass in parentheses response arrow get content as string parentheses. And let's perform the deserialization as well as check if it was successful by typing if in parentheses f JSON serializer double colon deserialize in parentheses pass in the reader as well as the JSON object. And then in squiggly brackets, if the deserialization was successful, let's check if the response content had a ticket ID field by typing if in parentheses JSON object arrow has field, and then in parentheses and in quotes ticket ID, and then squiggly brackets. If it does, then let's extract that field by writing f string matchmaking ticket ID and set it equal to JSON object arrow get string field in parentheses and in quotes ticket ID. And then let's set the matchmaking ticket ID variable in the game instance to the one returned in the response body. So to do that, let's retrieve the game instance by typing u game instance pointer game instance and set that equal to get game instance parentheses. Then perform a null pointer check, and then cast the game instance to our custom game instance class by running u GameLiftTutorial game instance pointer GameLiftTutorial game instance and set that equal to cast in carets u GameLiftTutorial game instance, and then in parentheses pass in the game instance, and do a null pointer check on that as well, just like we've always been doing it. And then here we can set GameLiftTutorial game instance arrow matchmaking ticket ID equal to matchmaking ticket ID. So after we have retrieved the matchmaking ticket ID and saved it in the game instance, let's now set the searching for game flag to true, because the request to make a matchmaking request is successful at this point. And at the same time, we can set pieces of text in the UI to reflect that as well. So let's go back to the very end of the on matchmaking button clicked function, cut these last 4 lines of code, not just copy, but literally cut them, and then go back to the last if statement of the onStart matchmaking response receive function, and inside there, just paste those 4 lines of code. And lastly, let's re-enable the button at the very end of this function outside of all these if statements by typing matchmaking button arrow set is enabled, and then in parentheses true. And the reason we are doing it outside of the if statements is that, like I said earlier, if anything goes wrong, even while deserializing the JSON response or storing the matchmaking ticket ID in the game instance, again, very low chance of that happening, but we should at least re-enable the button so they can always try to start a new matchmaking request. And in the cases where the deserializing of the JSON response and the storing of the matchmaking ticket ID in the game instance goes well, we should also re-enable the matchmaking button so that they have the option to cancel their matchmaking request as well. Now, moving on to the onStop matchmaking response receive function, believe it or not, what we do in here is actually very similar to what we do in the onStart matchmaking response receive function. So copy everything inside that method and paste it in here in the onStop matchmaking response receive function. But a few things are going to be different. So first, we are not going to be checking if the response body has a field called ticket ID. If you remember from when we coded the stop matchmaking function earlier in the tutorial, If everything went well in that stop matchmaking lambda function, then the response body will contain a field called success. So replace ticket ID here in the if JSON object has field statement with success. And we don't need to extract that field from the response body, so get rid of the line right below it. And instead of setting the matchmaking ticket ID to some actual string value like how we did in the onStartMatchmaking response receive function, we are going to be clearing the matchmaking ticket ID in the game instance because there is no longer a need for keeping it, since the matchmaking ticket associated with that ID is now finished, meaning it's no longer active. So replace where it says matchmaking ticket ID to the right of this equal sign with a pair of quotes signifying a blank string, and below that just get rid of these 4 lines that set the searching for game flag as well as some pieces of text. And at the end of this function, outside of all the if statements, we are going to set some pieces of text in the UI to reflect that the current matchmaking request is canceled and that the next time you click the button, it will be for starting a new matchmaking request. So go up to the on matchmaking button, click function, specifically in the big if searching for game block, specifically in one of these else blocks in that if searching for game block, and just copy the first 3 lines in one of these else blocks because we already have the setting of the matchmaking button to be enabled in the onStartMatchmaking response receive function. So go back to that function, and again, outside of all the if statements, at the end of the function, just paste those 3 lines of code. And the reason why I modified the UI like this, even if something went wrong with either the JSON deserialization of the response body or the clearing of the ticket ID in the game instance, is to again create that illusion to the user that their matchmaking request was canceled no matter what. But again, it is very, very rare that an error will ever occur during this process. And I just want to point out that I do indeed only clear out the matchmaking ticket ID if the request to the stop matchmaking API endpoint was successful. And there's no special reason as to why I chose to do this. It was mainly preference, because maybe in the very odd situation where something does go wrong, it may be worth keeping the ticket ID to see if the associated ticket caused issues. I know this technically goes against my illusion idea, but again, don't worry about it too much. There is so much flexibility with how you could write this entire project. So with that said, let's actually compile our project. So right click it and select build. And once your project is finished compiling, let's go back to Unreal Engine so that we can test these new changes. Now, before we continue, I would highly suggest pausing this video and opening up the DynamoDB dashboard, as well as the CloudWatch dashboard in the web browser of your choice, because I will be referring to CloudWatch logs as well as DynamoDB table changes while running this project. With that said, let's run the game and sign in with a valid username and password. And let's click on the matchmaking button, wait for the button to re-enable, and then let's quickly, before the matchmaking request times out, cancel the matchmaking request by clicking the button again. So a couple things to notice here. You saw that the matchmaking button was temporarily disabled while the HTTP requests were being processed, and like before, the UI elements were changing to indicate what was going on and the purpose of the matchmaking button. Now, let's go to CloudWatch and check some logs. So let's go to CloudWatch. And remember, like last time, under where it says logs on the left side, click on where it says log groups. And first, I want to check the logs for the start matchmaking lambda function to make sure that we pass player latency information to a call of GameLift start matchmaking. So find the log group for the start matchmaking function, click on it, and then again, by default, your log stream should be sorted by the latest event time in descending order. So let's click on the latest log stream. And let's click on the log, not the ones that start with start and the report in all caps. So expand this And as you can see, that makes sense because if you were looking at your screen while doing this, the ping was at around 25 when we clicked the matchmaking button to start a matchmaking request. So this makes sense. We have the region code as the name of the property in the latency in milliseconds object, and the value for that property is again 25. Next, I want to go back to check the logs of the track events function, which is currently subscribed to the SNS topic receiving GameLift event notifications. So it should have a log for both the message for the matchmaking ticket and matchmaking searching status, and the message for the matchmaking ticket, the very same ticket, and matchmaking canceled status. So let's go back to the log groups. Under where it says logs, we want all the log groups for every single Lambda function. And this time, let's find the, I believe, the track events Lambda function. So we just click on that. And then, like before, like we just did for start matchmaking, click on the log, the latest log stream. Now, since we're going to be looking at two messages here, you may have to look at two separate log streams. And by the way, if before we click on this, if you are expecting two messages in two separate log streams, then just click on the refresh button just to make sure. Now for me, it looks like both log messages are going to be in one log stream. So in my case, I'm just going to click on this log stream. And like I said earlier, don't click on the log messages that start with start, end, or report. So I'm going to click on this first one, since in this log events page, these log messages by default are actually sorted in ascending order from earliest time to latest time. So I'm going to click on the first one, and as you can see by this message, we have the ticket ID. So when we start a matchmaking request, we get an ID generated for us for our ticket, and you'll notice that the type of the ticket is matchmaking searching. And if we click on the next message, I'm going to call it quote unquote normal or custom message, the quote unquote custom message. So again, doesn't start with start, end, or report. So click on that message, and because we manually cancel the ticket ourselves, you should now see for the exact same ticket ID a message of type matchmaking canceled. And lastly, let's check the matchmaking tickets table in DynamoDB to see if we have an item for that ticket ID and that the type attribute of the item is matchmaking canceled, since we are only recording items for ticket events in one of our four matchmaking final result states. So from what we examined, let's click on the items tab to look at all the items in the table. Everything seems to look good here, because again, if you notice the ID of the item in this table, it is the same exact ID as, if we go back to the CloudWatch, the ticket ID that is logged to the track events function. And as you notice, it's the exact same one for when it was in matchmaking searching status as well. So if you want, we can go back to Unreal Engine and we can actually do it again. You can click the button, wait for it to re-enable, click the button again to stop a matchmaking request, and we can actually go back to DynamoDB and refresh the table just to see that there is a new ticket item with a different ticket ID that is also in matchmaking canceled state. Now we can go back to Unreal Engine and quit the game. Okay, so you were able to successfully start and cancel a matchmaking request. Just a quick note, if you did not cancel the matchmaking request in time, for instance, you waited more than the request timeout time, which is 60 seconds currently, before clicking the button to cancel the matchmaking request, then instead of that matchmaking cancel event in the logs for the track events function, you will see a message of type matchmaking timed out. And in the DynamoDB table, specifically the matchmaking tickets table, you will see an item of type matchmaking timed out instead of matchmaking canceled. But now how do we actually get into a game? So to do that, we are going to implement what is called polling, which is essentially just repeatedly sending HTTP requests to the server to fetch data. In that case, that data is specifically updates to our matchmaking ticket. And at one point, if the matchmaking was successful and we got into a match, then that data will contain connection information like an IP address and port that we can connect to where the server process is hosted on. Now remember that this is a tutorial, and for a production application I would not recommend this polling approach because it is not very efficient. You're constantly making HTTP requests there. You're opening and closing a connection constantly. A more efficient approach would be using a WebSocket API in combination with DynamoDB streams, because a WebSocket API just requires one connection request from the client, and a DynamoDB stream is basically just attaching a Lambda function to a DynamoDB table to watch for changes, similar to our track events function that is currently subscribed to an SNS topic, waiting for messages. And as this Lambda function receives information about changes to a table, it can send messages to the same WebSocket API that the client is connected to. And as long as the client is connected to the WebSocket, it will receive those messages without specifically asking for them. So I would highly recommend doing some more research in your own time if you want on WebSocket APIs. We will have links in the description below for more information on that. But for this tutorial, to make things really easy, let's go back to Visual Studio so that we can implement polling. And for polling the matchmaking tickets table, let's go to the main menu widget header file so that we can define everything we need for a timer function. So first we need a timer handle property. So let's go up here and under the one we already defined for the for setting the average player latency, let's type out u property parentheses f timer handle poll matchmaking handle. And after that, we obviously need the actual function. So let's go back down and type out the actual function. So u function parentheses void poll matchmaking is what we will call that function. And since this function will be making HTTP requests, we also need a response handler function. So type out void on poll matchmaking response received, and in parentheses, just like the four previous on response received response handler functions that we defined in this widget, let's just use the exact same three parameters from one of these four function definitions and paste them in here for our new on poll matchmaking response received function. Now let's go back to the main menu widget C++ class and actually implement this new poll matchmaking function. But before we do that, I just want to point out that I just found out that if you cancel a ticket that is in matchmaking timed out status, the call to GameLift.matchmaking will actually throw an error, and in that case, the response body will not have a success field. This may actually apply to tickets in matchmaking error and succeeded statuses as well, but I am not quite sure. So because of this new revelation, we're going to clear the matchmaking ticket ID field in the game instance no matter the result of the HTTP request to the stop matchmaking API endpoint. So cut everything inside the body of the if JSON object has field success statement, and paste it outside of these if statements before we apply the UI changes, and get rid of everything above. Now let's actually implement the poll matchmaking function. So let's type out underneath here void u main menu widget :poll matchmaking parentheses and then squiggly brackets. And in here we are going to first define a couple of local variables. First one is of type fstring and called access token because we need an access token to get access to the Cognito authorized API. And the second one is also going to be of type fstring but called matchmaking ticket ID because we need a key value to search on in the matchmaking tickets table. And then let's retrieve these values from the game instance by first getting the game instance by calling the getGameInstance method. And then let's do a null pointer check on the game instance. And then let's cast the game instance to our custom game instance class. So I'm just going to type it out just like we've always been doing it when we cast our game instance by calling the cast function, which will take in the game instance and then do a null pointer check on that as well on the game instance after it has been casted. And from there we can get the access token from the game instance as well as the matchmaking ticket ID. Alright, once we have the access token and the matchmaking ticket ID, we have everything we need to make an HTTP request to the pull matchmaking API endpoint. But before we make the HTTP request, let's first do a check on the length of the access token and the matchmaking ticket ID, just to make sure that we even have those values. Again, we usually will, but it's never bad to do an extra check. So type if in parentheses access token dot len parentheses greater than 0 double ampersand matchmaking ticket ID dot len parentheses greater than 0. And I'm also going to add double ampersand searching for game. And then let's add some squiggly brackets. Because since this function will be called on a timer interval, I want to make sure that there is never a race condition in which maybe the user just clicked the matchmaking button to cancel a request, and then milliseconds later this pull matchmaking function gets called, and therefore an HTTP request gets made. It's already not that likely since timer functions in Unreal Engine are technically synchronous, but again, it doesn't hurt to have an extra check. And then in here, let's make the request body, which will only contain a ticket ID field. So for that, we need a JSON object. So let's type out t shared ptr and then in carets f JSON object, and we'll call this variable request obj, and we'll set it equal to make shareable in parentheses new f JSON object. And then, of course, as I just said, we're going to set the field inside this request object by calling setString field, and we're going to pass in two parameters. First one is going to be the name of this field, which is going to be in quotes ticket ID, and then the second parameter is going to be the actual value, which is the matchmaking ticket ID. And we also need a fstring variable to hold the JSON formatted request body string, and to actually do the serialization, we also need a t JSON writer object. So type out t shared ref in carets t JSON writer, then in carets, and then we'll call this variable writer, and we'll set it equal to t JSON writer factory, and then carets double colon create, and then in parentheses ampersand request body. Now let's perform the serialization and check if it was successful by typing if in parentheses f JSON serializer double colon serialize, and then pass in parentheses request obj.to shared ref parentheses comma writer, and then squiggly brackets. Then make the HTTP request by typing t shared ref and then in carets I HTTP request, and we'll call this HTTP request pull matchmaking request, and we'll set it equal to HTTP module arrow create request. Next, set the response handler function by typing pull matchmaking request arrow on process request complete parentheses dot bind u object in parentheses this comma ampersand u main menu widget double colon on pull matchmaking response received. And we will be implementing this on poll matchmaking response received function very shortly. Next, set the URL of the request by typing poll matchmaking request arrow set URL in parentheses, and remember that the endpoint will be the API URL plus the resource name, which is in quotes / poll matchmaking, since we are going to be hitting the poll matchmaking API endpoint. And make this request a post request by typing poll matchmaking request arrow set verb in parentheses and in quotes post. And let's add 2 headers to our request. For the first one, let's type poll matchmaking request arrow set header, and then this one will be called content-type, and the value for it will be application/JSON. And for the second header, let's type poll matchmaking request arrow set header, and this one will be called authorization, and the value for it will be the access token. Next, let's set the request body by typing poll matchmaking request arrow set content as string, and in parentheses pass in the request body. And finally, send the request by typing poll matchmaking request arrow process request. And before we move on and implement the response handler function, I just realized that I forgot to set the content type header to application/JSON for an HTTP request that we made. And that was a request to the getPlayerData API method. So let's scroll back up to where that HTTP request was made and just add that content header here by typing getPlayerData request arrow set header, and then in parentheses pass in quotes content-type as well as in quotes application/JSON. Now, I also forgot to include it when we call the API GameLift service endpoint, but in that function we don't send data through the request body, nor do we parse the response body. Since the getResponseTime function is only meant for determining how long it takes to get the response from the endpoint since making a request. And again, I do apologize for going back to make corrections. These tutorial videos tend to be long, so if I do find out mistakes in the middle of recording, I am not going to re-record huge amounts of footage because it is not worth it. With that said, let's scroll back down and write the method signature for on-poll matchmaking response received. So type out void uMainMenu widget :on poll matchmaking response received, and in parentheses pass FHTTP request PTR request, FHTTP response PTR response, and bool B was successful with a pair of squiggly brackets. And in here, let's not only check if the request was successful, but also let's check if the client is in the searching for game state by typing if in parentheses B was successful $ampersand searching for game, and then squiggly brackets. Now keep in mind that this response handler function will be called when we receive a response, and that won't happen right away after calling process request. So there may be a moment in time where poll matchmaking gets called, an HTTP request gets sent to the poll matchmaking API endpoint, and then the user presses the matchmaking button to cancel a request before a response comes back, and this function that we're in now gets called. Now, if the user beat the HTTP request in a race, then I prefer trying to do what the user wants, which is basically that they want to cancel, quote unquote, they want to cancel that matchmaking request. When this function gets invoked, the response payload passed to this function could have been anything. There could be no ticket field in that response body because the ticket was still in matchmaking searching status, or the ticket was in one of the 4 final states. For all of those states besides matchmaking succeeded, the user was not going to end up in a game on the server. But in the matchmaking succeeded state, the user would have ended up in a game on the server, and that's what this check, this searching for game check, is trying to prevent. In the very, very rare case where the user clicks the button, sets searching for game to false, before that specific ticket event occurs. So in that very rare race condition, the user doesn't end up in a game. Now let's make a JSON object as well as a tJSON reader for parsing the JSON formatted response content. So type out t shared ptr and then in carets f a JSON object, JSON object, and then type out t shared ref in carets t JSON reader, carets, we'll call this variable reader instead of equal to t JSON reader factory carets double colon create, and then in parentheses pass in response arrow get content as string parentheses. And let's actually perform the deserialization as well. Oh, actually, sorry about that, guys. I missed the Y there, made a typo. And let's actually perform the deserialization as well as check if it succeeds by typing out if in parentheses f a JSON serializer double colon deserialize, and then in parentheses pass in the reader as well as the JSON object, and then add some squiggly brackets. And let's check if the response body had a ticket field, because if it did, then that means there is a ticket in the matchmaking tickets table with the ticket ID specified in the request, which means that the matchmaking ticket is in one of the 4 final result states. So type out if in parentheses JSON object arrow has field, and then in parentheses pass in quotes ticket. And then squiggly brackets. If it does, then let's parse out this ticket object by typing t shared ptr in carets f JSON object, call this variable ticket and set it equal to JSON object arrow get object field, and in parentheses pass in ticket again in quotes. And let's get the type attribute from this ticket object by typing f string ticket type and set it equal to ticket arrow get object field in parentheses and in quotes type. And remember, the weird thing about items in DynamoDB is that they're not only, the weird thing about items in tables in DynamoDB is that their attributes are technically objects, and then in this object there's one property where that is the actual value. So after you do get object field, do arrow get string field, and then in parentheses and in quotes pass s. And then let's just do a simple length check on the ticket type to make sure that it is not empty. So type out if in parentheses ticket type dot len parentheses greater than 0. So if a ticket item is returned and it has a type attribute, a valid type attribute, then that is enough information for us to know that the matchmaking request is finished. Could have succeeded, could not have succeeded. So let's write some code to quote unquote reset our client. So one of the things we need to do is stop calling the poll matchmaking function, because there's no point. We now know the final state of the matchmaking ticket, and since the poll matchmaking function will be called in a loop, let's clear the timer by writing get world in parentheses arrow get timer manager parentheses dot clear timer in parentheses poll matchmaking handle. That timer handle is, we are going to use that later to set the actual timer to actually call the poll matchmaking function shortly. In addition to that, let's also set the searching for game state of the client to false. So let's type out searching for game equal false. Because with no active matchmaking request, you are no longer searching for a game. And lastly, let's clear the matchmaking ticket ID value in the game instance, because the corresponding request is now dead. So there's no point in keeping any references to it. We actually already did this in the onStop matchmaking response receive function. So I am going to go up to that function and I'm going to copy the lines of code from where we retrieved the game instance to where we cleared the ticket ID. And then go back down to the onPoll matchmaking response receive function and then just paste it in there. Now we have to determine what we want to do depending on the final state of the matchmaking ticket. To start, let's deal with the case where we get into a match. So type out if in parentheses ticket type dot equals in parentheses and in quotes matchmaking succeeded. and then a pair of squiggly brackets. And the first thing we are going to do if matchmaking succeeded is disable the matchmaking button, so that while the user is in the process of connecting to the server, they don't start a new matchmaking request. So let's type out matchmaking button, arrow set is enabled, and pass in false in parentheses. Then let's set the matchmaking event text to let the user know that they're about to join a game. So type out matchmaking event text block, arrow set text, and then in parentheses pass f text, double colon from string, in parentheses and in quotes, successfully found a match, now connecting to the server, ... And then let's further parse the ticket object so that we get everything we need to join the server. So let's first get the game session info by typing out t shared ptr in carets f JSON object. Call this variable game session info, and we'll set it equal to ticket arrow get object field in parentheses and in quotes game session info. Remember that in DynamoDB, it's kind of weird because the items have attributes with values in them, but the actual value of the attribute is within an object named after the attribute, and this object has a property called that is basically named a certain letter depending on the type of attribute it is, and then the value of that property is the actual value. So we have to do, in addition to this, arrow get object field in parentheses and in quotes m, because this is a map. Technically this is a map attribute. So then let's get all the connection info, like the IP address and port, from the game session info by writing f string IP address and set it equal to game session info, arrow get object field in parentheses and in quotes IP address, and then arrow get string field in parentheses and in quotes s, and then f string port equal game session info, arrow get object field in misspelled field, and then in parentheses and in quotes port get string field in parentheses and in quotes n. And for those who may have forgotten, remember that the S letter stands for string in this case, and the N letter stands for number in this case. And I know it's weird, again, that the port is technically a number field, but it comes out as a string. That's just how DynamoDB does it. I don't know why. Then let's get the player session ID and the player ID from the ticket so that the client can pass those to the server while connecting, since that is what the GameLift documentation recommends. Now remember that a ticket can technically have multiple players associated with it. So the ticket will have an array field called players when it's in the matchmaking succeeded state. So let's type out t array in carets t shared ptr, and then in carets f JSON value. And we'll call this variable players, and we'll set it equal to ticket arrow get object field in parentheses and in quotes players. And then we need to get the actual value of this attribute, which is technically an array. So type out arrow get array field, and then in parentheses and in quotes, the letter that represents the array attribute is L. However, for this tutorial, we will be assuming that each ticket will only have at most one player associated with it. So let's get the first player in this array and get the map property from it so that we can get the player session ID and player ID from this player map object. So type out t shared ptr in carets f JSON object. We'll call this variable player and set it equal to players square bracket 0, which represents the first element in the players array. And then arrow as object, because as object in parentheses, because as you may have noticed already, the players array is an array of t shared pointers to fjson values, not fjson objects. So to get the actual fjson object from the fjson value, we have to call as object on the pointer to the fjson value. So once you call as object, do arrow again, and then get object field in parentheses and in quotes m. because the player's attribute is an array of map objects. So now we can get the player session ID and player ID by typing out fstring player session ID, set that equal to player arrow get object field, and then in parentheses and in quotes player session ID, and then arrow get string field in parentheses and in quotes s, and type out fstring player ID equal player. Sorry about that, guys. I misspelled player, meant to have a capital P there. So as I was saying, player arrow get object field in parentheses and in quotes player ID, and then arrow get string field in parentheses and in quotes s. Then let's combine the IP address and the ports so that we can connect to the server, and store that value in a variable of type fstring called level name, and set that equal to IP address plus in quotes colon plus port. And then let's construct the options, which will contain the player session ID as well as the player ID that we are going to pass to the server. So type out const fstring ampersand and call this variable options and set it equal to in quotes question mark player session ID equals, and then plus player session ID plus in quotes question mark player ID equal plus player ID. And finally, let's connect to the server by calling the open level function. So type out u gameplay statics double colon open level, and then in parentheses this open level function will take in 4 parameters. The first one will be the world, so type get world parentheses. Second parameter will be fname in parentheses star level name, so the name of the level, which should have the IP address and port. Third parameter is going to be a boolean representing whether or not we want the options to be carried over from the current level, so that's going to be false. Don't really care about keeping the options as we travel through different levels unless you want to. And then the last parameter will be the options that you want to pass while connecting to the level. And you may have already noticed there is a red squiggly line underneath where it says u gameplay statics, the class where the open level function comes from. So we are missing an include statement. So let's scroll to the very top of this C++ class and just type out hashtag include and in quotes kismet slash gameplay statics dot h. And then let's scroll back down because I actually want to add a log statement, because this will be very important later on. So after we made the options variable, let's just type out ue underscore log in parentheses pass in log temp comma warning comma text, and then in parentheses and in quotes type out options colon %s, and for this string placeholder let's type out star options. And the reason why I'm logging the options here, by the way, I misspelled UE log. The UE underscore log has to be in all caps. But the reason why I want to log out the options is because we have to just make sure later that we are indeed passing the player session ID and the player ID to the server when we join it. Because later on in the next part of the tutorial, we will need those player session ID and player ID values for GameLift and matchmaking purposes. And to finish this function, let's deal with the case where the ticket is in either the matchmaking canceled, failed, or timed out states. In all 3 of these final result events, we are going to do the same thing. Just set the button text back to join game, as well as set the matchmaking event text to let the user know what happened to their request. So online with this if ticket type dot equals matchmaking succeeded block, let's add a else. And then squiggly brackets, u text block pointer button text block, and set that equal to in parentheses u text block star, and then matchmaking button arrow get child at in parentheses 0, and then let's set the text by typing out button text block arrow set text in parentheses f text double colon from string in parentheses and in quotes join game. and finally matchmaking event text block, arrow set text, in parentheses, f text, double colon, from string, in parentheses, we're going to pass in the type of the ticket, the type attribute of the ticket, so we'll tell them either matchmaking canceled, failed, or timed out, plus, in quotes, dot, please try again. And before we move on from this function, I do want to point out that we are assuming that the call to open level will always succeed, even though this is not technically the case. I just want to make this tutorial a little shorter, but if you do want to deal with that case where open level fails, you can assign a on-travel failure delegate function to the engine to handle that. But moving on, the question now becomes, when will the poll matchmaking function ever get called? We said earlier that it would be called in a loop in a timer interval, so we have to set the timer somewhere. So let's go to the onStart matchmaking response receive function. And in the case where we successfully started a matchmaking request and got a ticket ID back from the response, we should begin polling the matchmaking tickets table for updates to our request. So before we set searching for game equal to true, let's call set timer to run poll matchmaking once a second. So type out get world parentheses arrow get timer manager, and then parentheses dot set timer, and then in parentheses this function, remember, takes in 6 parameters. First one is the timer handle, so we're going to pass in poll matchmaking handle. The second parameter is going to be this. Third parameter is going to be the address of the function that we're going to call, so it's going to be ampersand u main menu widget double colon poll matchmaking. Fourth parameter is how often we want the function to be called, so like we said, 1.0f once a second. Next parameter is, do we want this function to be called in loop? Answer is yes, so we're going to pass in true. And last function is the initial delay in seconds, so that will also be 1.0f. So that's where we start calling poll matchmaking, but when do we stop calling poll matchmaking? We already dealt with one of the cases in which that happens, which is when we poll the matchmaking tickets table and we get an item back, indicating that the matchmaking request has reached its final state. So we cleared the poll matchmaking timer handle variable in that case. But there is another case where we should clear the timer handle, and that is when the user clicks the matchmaking button to cancel a matchmaking request, because if they want to cancel a request, then they should no longer be polling for updates on that request. So go back up to the on matchmaking button, clicked function, specifically in the if searching for game block, before we set searching for game equal to false, and type out get world parentheses arrow get timer manager parentheses dot clear timer in parentheses pass in poll matchmaking handle. And then after that, let's go ahead and build our project. Once the project is finished building, let's go back to Unreal Engine and test our changes. So play the game and sign in with a valid username and password, and make sure you start and stop a matchmaking request like before. So let's sign in, because that functionality that I just described should have remained unaffected. So I'm going to click join game to start a matchmaking request. I'm going to cancel that matchmaking request, and then click on the matchmaking button again to start a new matchmaking request. But this time, wait 60 seconds to let the request time out. Just don't do anything for 60 seconds. Don't click the cancel matchmaking button, because if everything works, if the request times out like it should, you should see in the middle of the screen the text change from currently looking for a match to matchmaking timed out, please try again. So after about 60 seconds, you see that the text in the middle of the screen changed, as well as the text of the button. So just to double check that everything is normal, let's go to the matchmaking tickets table in DynamoDB, click on the refresh button to see the items, and that looks pretty normal here. We should see 2 new items. We should see one of type matchmaking timed out, and one of type matchmaking canceled, because again, we were just testing out the old functionality, making sure that was still working. And if we go to the CloudWatch logs, specifically for the poll matchmaking function, let's look at the latest log stream. you may have to look at multiple log streams, but so if we scroll up here, for me it says there are older events to load more, so I'm actually going to click on that. I actually want to load more events, and I'm going to actually continue loading some events here. Okay, so no older events at this moment. So as you can see, so if you look at the timestamps on the left side here, you'll notice that, like, for me around 5:52 it started polling. So it looks like with that outlier at the beginning, or minus that outlier in the beginning, it seems to be calling poll matchmaking every second. So that's pretty normal. Oh, okay, I actually know why there's a 5-second gap here. There's about a 5-second gap because remember when we first click on the matchmaking button to start a matchmaking request, we almost immediately cancel that request. So in that very short brief period of time, it did try to check the status of the matchmaking ticket once. And after that, after I canceled the matchmaking request, I clicked on the join game button again to start a new matchmaking request. And from there, as it was timing out from 5:52:33, so all the way up to 5:53:33. See that makes sense, right? Because our request timeout is about 1 minute 60 seconds. So it kept pulling the matchmaking table for about 60 seconds, and you'll notice the gap right now is once every second. So let's go back to the Unreal Engine editor, and I would actually recommend clicking on the matchmaking button again to start a new matchmaking request and do the exact same thing. Just wait 60 seconds, let the matchmaking request time out, make sure that the text changes for the middle of the screen as well as the button. Go back to DynamoDB, make sure that a new item was added, and in addition you can also check the CloudWatch logs for the poll matchmaking function. Just make sure that it was constantly getting called every second. And once you have done that, make sure that everything still works after a second try. Again, just check your CloudWatch logs, make sure that you know that the poll matchmaking function is getting called once every second. So it seems like, again, starting from 6:02, it was being called every second according to the CloudWatch logs. Again, DynamoDB, refresh your table, make sure that there's a new item of type matchmaking timed out. Everything seems to look good in this case, so let's actually stop playing the game. Okay, so I know you guys are dying to test multiple clients, but there are still a few minor things that we have to add to our code. So first, it is recommended to clear out your timers when you are not using them. So let's go to Visual Studio, specifically the main menu widget header file. And in the main menu widget, we have a lot of timer functions that should not be executed when the widget is gone, whether we quit out of the game or leave the main menu map to go to the third-person example map on the server. So there is a user widget built-in function called native destruct that gets called when the widget gets destroyed or removed from the UI. So let's override it by going up and typing under the native construct method definition. Let's type out virtual void native destruct parentheses override. And then let's go back to the main menu widget C++ class and actually implement this function. I'm going to do it right below where we implemented the native construct method. So underneath here, let's just type out void uMain menu widget native destruct parentheses and then squiggly brackets. And unlike the native construct method, we are not going to call the superclass's native destruct method first. We're actually first going to clear the timer. So to do that, let's type out get world parentheses arrow get timer manager parentheses dot clear timer in parentheses poll matchmaking handle, because that is one of our timer handle member variables in this class. And let's do it the exact same thing for the other timer handle member variable by typing out the exact same thing, get world get timer manager parentheses dot clear timer, and then in parentheses pass in the other timer handle, which was called set average player latency handle. And then after that, after we have cleared both timers, now let's call super native destruct. And the reason why I'm doing this after clearing the timers is because native destruct gets called when a widget is no longer referenced, causing the slate resource to be destroyed. Now, I want to do my own custom cleanup stuff first before the widget takes over and does whatever it's written to do. And we also have timer functions that we should clear in the game instance class as well. So let's go to the game instance C++ class, specifically up in the shutdown method, because in here is where the game instance performs cleanup operations while the game is shutting down, which makes it a perfect candidate function for clearing timer handles. So at the very beginning of this method, before we call the parents game instance class shutdown method, let's clear both the timer handles we have in this class by typing out get world parentheses arrow get timer manager parentheses dot clear timer in parentheses. Let's pass and retrieve new tokens handle, and then let's clear the other timer handle by typing the exact same thing, get world get timer manager dot clear timer, and then in parentheses pass in the other timer handle, which was called get response time handle. And the reason why the timers have to be cleared before calling the superclass's shutdown method is that the super shutdown method clears the pointer to the world context object. So the call to get world would end up returning a null pointer. So when we call get timer manager on get world, an exception would be thrown. In fact, I would actually prefer moving this call to super shutdown method to the bottom of this custom implementation of the shutdown method, just to be safe. So let's highlight the super shutdown, let's cut it, press Ctrl X, and let's paste it at the very bottom of this method. And the argument for doing this is similar to what we did in the main menu widget class with the native destruct method. Again, it's just to be safe. Even though Unreal Engine will wait for HTTP requests to finish before shutting down the game fully, I don't think it's a bad idea at all to do all of our custom cleanup before doing whatever the game engine is written to do. So with that said, let's go ahead and build our project. And let's go back to Unreal Engine and just play the game again to make sure everything still works, nothing crashes. So let's sign in with a valid username and password. And then let's click the button to start a matchmaking request. And let's click it again to stop that request. Seems that everything is still working. Now let's click the button again to start a matchmaking request again. Now notice how the only way for the current matchmaking request for this particular client to get canceled is if the player clicks the matchmaking button again. If I quit out of this game, shouldn't we cancel the matchmaking ticket? Because once the user quits the client while in the middle of a matchmaking request, there's no way at the moment that the user can pick that request back up again, because it's not like we saved the matchmaking ticket ID to anywhere external. We could, but for this tutorial we are not going to do that. Instead, if the user quits, then we are going to cancel the ticket if an active one exists. So let's quit the game. Let's go back to Visual Studio, and we are already in the perfect method to make this HTTP request to the cancel matchmaking API endpoint in the shutdown method. So in here, in the check for the access token length, let's make the HTTP request to the stop matchmaking API method if the matchmaking ticket ID is not empty, because if it is not empty, then that means that ID is currently linked to an active matchmaking ticket. So let's first check if the ticket ID is empty by writing if in parentheses matchmaking ticket ID.len parentheses greater than 0 squiggly brackets, and then let's make the JSON object with a ticket ID field by writing t shared ptr and then in carets of JSON object, and we'll call this variable request obj, and we'll set it equal to make shareable, and then in parentheses pass in new f JSON object. And then in this request object we will set a string field, and that string field will be called in quotes ticket ID, and the value for it will be the matchmaking ticket ID. Then for the request body we need a string variable as well as a t JSON writer variable. So I'm just going to write out t shared ref t JSON writer carets, call it writer, and so equal to t JSON writer factory caret double colon create, and in parentheses pass an ampersand request body. And then let's serialize the JSON object into a JSON formatted string and check if that is successful by typing if in parentheses f a JSON serializer double colon serialize, and then in parentheses pass in request obj.to shared ref parentheses as well as the writer object, and then in squiggly brackets let's make the HTTP, sorry about that, made a typo, and then in squiggly brackets let's make the HTTP request. So type out t shared ref and carets my HTTP request, and we'll call this HTTP request stop matchmaking request, and we'll set it equal to HTTP module arrow create request, and then let's set the URL of this request by typing stop matchmaking request arrow set URL, and then in parentheses the URL will be the API URL plus in quotes / stop matchmaking. And then this is a post request, so let's type stop matchmaking request arrow set verb, and then in parentheses and in quotes post. And then let's add the content type as well as the authorization headers by typing stop matchmaking request arrow set header in parentheses and in quotes content dash type, and then comma in quotes application / JSON. And then also type out stop matchmaking request arrow set header in parentheses and in quotes authorization, and then comma access token. And then pass the request body by typing stop matchmaking request arrow set content as string, and then in parentheses pass in the request body. And finally send the request by typing matchmaking request arrow process request. Notice again that we did not bind a response handler function to the HTTP request because the game at this point is shutting down, so there won't be much time to handle a response from the API. With that said, let's go ahead and build our project. And then once the code has compiled, let's go back to Unreal Engine. But before we start the game, let's quickly go to the matchmaking tickets table in DynamoDB and refresh the items in the table so that you can see all the latest items in your table, and notice what's already in there so that we can easily tell when a new item is added to this table. Now let's go back and play the game and sign in with a valid username and password. And then once you have signed in, just go ahead and click the matchmaking button to start a request. But this time, instead of clicking the button again to stop the matchmaking request, just quit the game either by pressing escape or clicking the stop button. Now go back to the DynamoDB page, specifically the matchmaking tickets table, refresh the items inside, and if everything worked, then you should see a new item in the matchmaking tickets table of type matchmaking canceled. For me, that new item was this bottommost item that just appeared. And now we have one more thing left to code before we package the client, which is we have to deal with the case in which the game on the server ends and the client comes back to the main menu map. Now when the clients travel back to the main menu level, the UI elements that the user saw before traveling to the server are no longer there. Those UI elements were destroyed, and once the user comes back to the main menu, those UI elements, which includes everything, the button, the web browser widget, and the text blocks, all have to be reconstructed. And we do not want a user to come back to the web browser widget after a game on the server ends, because that user should not have to re-authenticate themselves, especially because the access token is still on the game instance. Remember, even while traveling between the main menu and the server maps, everything on the game instance stays intact. So since we just mentioned that the UI elements get reconstructed, upon coming back to the main menu, our main menu widget native construct method will get called. So let's go back to that method in Visual Studio. And let's first get the access token before we clear the web cache. So after we set the timer for the set average player latency function, let's type out fstring access token, and then let's get the game instance and set that equal to a variable called game instance. And then let's do a null check on the game instance. And then let's perform a cast on the game instance to our custom game instance class. So we're gonna set that to a variable called GameLiftTutorial game instance. And then remember, the cast function will take in one parameter, and that parameter will be the game instance. And then let's do a null check on that as well, just like we've always been doing it. And in here, let's set the access token local variable to GameLiftTutorial game instance arrow access token. Now, if the access token exists on the game instance and is equal to an actual value, then that most likely means that the client has already authenticated itself and most likely came back from a match, which means that they should not have to re-authenticate themselves, and we can go ahead and make an HTTP request to the getPlayerData API endpoint so that we can populate the text block. So let's check if the access token length is greater than 0 by typing out if in parentheses access token dot length parentheses greater than 0, and then squiggly brackets. And like I just mentioned, we can go ahead and just call the getPlayerData API endpoint because the response handler function will handle all the UI stuff for us. And we already made this HTTP request earlier in the onExchange code for tokens function. So go down there and copy these last 7 lines of the function, last 7 lines of code in the function, starting with the creation of the HTTP request to the calling of process request. And then go back to the native construct method and paste it inside that if statement that we were just on. And of course, if the access token length is not greater than 0, then most likely the client has not authenticated itself yet, and this is them just opening up the game before playing any server matches on that particular instance of the game client. So in that case, we should load up the Cognito hosted UI URL in the web browser widget. So enclose all of this code after the if access token length greater than 0 block in an else statement like so. So right after this if statement, I'm just going to type in else and then some squiggly brackets, and then again the rest of the code in this function, let's just copy it, or actually let's cut it and then paste it inside this else block. And then once you've done that, let's build our project. Once the project is finished compiling, go back to the Unreal Engine editor and play the game just to make sure that the core functionality has not been affected at all. It still works, so just sign in and then click the matchmaking button. Make sure you can still start a matchmaking request, cancel the matchmaking request, make sure you can still do that. Quit the game, make sure nothing crashes. Seems like everything still works. Just a caveat that we can't actually test that new code we just added to the main menu widget until we actually package our client, because the only way to test whether or not the client doesn't have to log back in after finishing a game on the server, we need to actually have a client join a game on the server and then come back to the main menu map. With that said, let's go ahead and package the client, but before we do so, we have to modify the packaging settings a little bit. So go to File, then go to Package Project, and then go to Packaging Settings. And make sure, just scroll down here, scroll down to where it says List of maps to include in a package build. And if you remember from last time, we already have a map for the third-person example map, since this is the map used on the server. Let's add another map, the main menu map. So click on this plus button by where it says One Array Elements, and then in this new text field that appears to the right of it, click on the click on the 3 dots, and then in this folder select the main menu map, and then click on Open. Then we also need to package the URLs in the content folder with the client as well. Otherwise the client won't be able to reach the API. So by where it says if we scroll down here a little bit, by where it says additional non-asset directories, the package, click on this plus button to the right of it, and then click on the three dots, and that should take you to this file explorer like window with everything in the content folder. So in here, select the URLs folder and then click on select folder. And lastly, this is up to you, but down here you can choose not to include debug files. I selected this checkbox before in an earlier part of the tutorial because I thought it could be useful and easier for you guys when debugging your server builds. But it's not that necessary for client builds. All it does is just add the PDB files to your package builds, which not only are used for debugging, but also it gives you the exact line numbers and classes where specific errors and logs occur. But PDB files can sometimes give away too much information, like how the code is written in your project. So for a production application, I would turn this option off. In fact, I'm going to turn this option off now. And when we package server builds again in the next part of the tutorial, we will turn this option back on. Also, not including PDB files in your client build makes it smaller in size as well. Now, when making package builds for the server, in my opinion, it is still worth including the PDB files because unlike a client build, you're not supposed to share a server build with people you don't trust. And you can argue that you shouldn't trust AWS, but for this tutorial, we will. And you will later see in a future part of the tutorial that when we remote connect to the server, having the PDB files later, or having the PDB files packaged with the Unreal Engine game server build will help you tremendously. For instance, when your server crashes and you go to check the logs on the server, they won't give you much useful information and would be hard to read without the debug files. Although the PDB files do make the server build a lot bigger, which makes it a little slower to upload the build to the server, in my opinion, again, it is completely worth it. Even when your client crashes, you as the creator of your Unreal Engine project have the PDB files. It's just that you don't want other people who don't know who you distribute the client build to use the stack trace from the logs to reverse engineer your program. And if you want, you can have users send their client logs to you for you to debug, since you will have the PDB files and can use them to properly read those logs. Again, whether or not you include debug files in a package build is up to you. Okay, now let's close out of the packaging settings and go back to File, Package Project, and for the build configuration, make sure that you have development selected, or really just make sure you have anything but shipping selected, because we need to see logs in general for testing at least this first client build in order to make sure that we're getting and passing a player session ID and player ID to the server. After that, you may go back to make shipping builds if you want, and then after that, make sure for the build target that you have GameLiftTutorial selected instead of GameLiftTutorial server. And then go ahead and package the client by going back to File, back to Package Project, and we're going to be making a client build for Windows, so select Windows, and my machine is 64-bit, so select Windows 64-bit. And as for where you store the client build, I just store it in the same directory as where my main project is, so because that's the default. So just click on select folder, and if you want, you'll see this pop-up showing same packaging project for Windows 64-bit on the bottom right of the screen. Click on show output log if you're not already in the output log window, and if you want, you can look at the logs while the project builds. Once the project has finished packaging, let's go to our project in File Explorer and make sure that you can now see a new folder called Windows New Editor. Double click it to open it, and you should see an executable inside of here named after your project. Now, in this tutorial series, we will be opening the game client in windowed mode, specifically at a specific frame size, so that we can open up multiple clients on one screen. So in File Explorer here, actually in the search bar, you can actually do this in the command prompt as well, but I think it'd be easier just to do it from here. You can type in GameLiftTutorial.exe and then pass in parameters ResX equal 950, ResY equal 950, WinX equal 950, and WinY equal 950. The resolution of my monitor is about 1920 by 1080, so that's why I'm choosing these specific size parameters, because again, I want to try to get two client windows fitting on this one screen for you guys. So I'm going to press enter, and you're gonna notice right away and probably be confused that this application opened up in full screen mode. That's okay, just click on F11 and you'll notice that now it's in windowed mode at the size that you specified. So you can click, well, right now your mouse may be confined within the screen, but you can click anywhere on it inside the application to lose focus on the UI, and then you can select this white bar here at the top of this game window and just drag this window to move it. And then let's do the exact same thing. Let's type that same command. I'll have this in the description, by the way. GameLiftTutorial.exe ResX equal 950, ResY equal 950, WinX equal 950, and WinY equal 950, and press enter. And I'm actually not even too sure if you need to type that command again. Unreal Engine might be smart enough to actually remember those the parameters you used from last time. But okay, so we have another window. It opened at a pretty bad spot, so let's click anywhere on in the application to lose focus on the UI, and then drag the window up here. Okay, so now we have two clients. So just for testing purposes, I want to show you guys first why I mentioned earlier that we should not ever test multiple clients logged into the same account. So I'm going to log into the same account on both clients. So as you can see, I'm logging in through the Cognito identity provider using my Floparam account. So again, same account here. And what I'm going to do is on one of these clients, I'm going to click on the Join Game button to start a matchmaking request. And then once I'm currently looking for a match, I'm going to go back to the other client and do the exact same thing. I'm going to click on the matchmaking button. And notice what ends up happening on the client on the right side of the screen. The button changed back to saying join game, and in the middle of the screen it said matchmaking cancel, please try again. Now if you try to have, in GameLift you can only have one active matchmaking ticket per unique player ID at a time. If you try to have multiple active matchmaking requests for a specific player ID, then GameLift will cancel the older requests automatically and keep the newest one active. In our case, the player ID is the user's Cognito sub ID, so it is a unique value tied to the user currently logged in. And also remember, if you quit one of these clients, so I'm just going to click out of this one on the left here. I'm just going to click this X button to close out of it. If you quit out of one of the clients, the other client will eventually break in about an hour, because once the access token expires, the client still open right now won't be able to get a new access token, because when you quit out that other client that we just did, it invalidated all the refresh tokens out there for that specific user. In fact, this client right now could be broken. The access token could just be invalid right now. But we're not gonna find that out. Just keep in mind, in this tutorial, throughout the series, please try to not test with multiple clients logged into the same account. We're trying to test under perfect circumstances here, just to keep things simple. So let's close out this client. And before we open two new game client instances, I just want to let you guys know, make sure to have the GameLift dashboard as well as the DynamoDB and CloudWatch dashboards open up in the web browser of your choice. With that said, let's go back and open up two new instances of the game client. So this time just double click it to open it, because the executable should be smart enough to remember our settings from before, so we should not have to retype that command every single time. Maybe for when we want to change the size of the game client window. Again, let's click on here to lose focus and move this game instance window to the left here, and let's open another instance of the client. Same thing, just click anywhere on the UI to lose focus and move this to the right side of the screen. Okay, but this time let's log in with two separate accounts. I'm actually going to use the Google identity provider for one of these accounts. So again, you're gonna have to sign in with a newer Gmail account, otherwise this won't work. I don't know why. Again, I'm pretty sure it's an issue with the Unreal Engine source code, the fact that it uses a very, very old version of Chromium. And then for the other account, I'm going to use the Cognito identity provider, because I've been using that throughout the tutorial series. And remember, you don't have to use different identity providers when testing. You can log in using one identity provider for all the accounts you use. Just make sure that you are signed in to different users. Now for the moment of truth. Press the matchmaking button in both clients and hopefully you end up in a match together. Now it may take some time since we're using we're using polling instead of, WebSockets, so it's not going to be real time, but as you can see, it works. Now, something to keep in mind, I know there's an extra pawn in here. That's because I'm an idiot. In a previous part of the tutorial, I forgot to remove this pawn from the server map from a separate video. But we'll do that again in the future. We'll make sure that we get rid of it. Now, the only annoying part about this, I would say, in order to switch clients is that you have to use Alt-Enter to switch between the different windows. So I'm not a big fan of that. But as you can see, they are both in the same match. Now let's go to the Amazon GameLift management dashboard, go to the fleet, go to the tab labeled game sessions, and in this one active game session, click on the ID here, and that'll take you to the list of player sessions. Now right now the player sessions are timed out, but I promised you guys at one point this timed out here did say reserved. So I know a lot of people have asked me in the past, it is technically true, you don't need a player session to technically be on the server. You don't need your player session to be active to be on the server, although that's not a good practice, and in the next part of the tutorial we will address this. But notice the total time was 1 minute pretty much exactly. That's because player sessions are reserved for 1 minute, and then it's up to the server and the client to work together so that once the client joins the server, and that's why again we passed that player session ID and player ID. So once the server gets that data from the incoming client, it'll know, okay, do these player session IDs and player IDs, are they valid? If they are, then we'll activate the player session, make it active, and this timed out will actually say active. But that's going to be in the next part of the tutorial. Now let's actually go back to File Explorer and check out the client logs to make sure that the player session IDs and player IDs line up with the ones we see here. So go back again to File Explorer, specifically the Windows No Editor folder in your project, and then inside here open up the folder named after your project, then open up the save folder, and then open up the logs folder. Now right now the logs for our current running builds are labeled project and then project_2, and then underneath that you have a bunch of backup log text for when the game was basically a couple things can cause these backup files to be generated. One, you open the game up again, so it just moves the logs from the previous time your game instance was opened down to another log file, or the log files for one running active instance get so long that it has to break up some of the logs to keep these log files around the same size. I think, it's like, I really don't know how long they usually keep the log files size wise, but let's open up the GameLiftTutorial.txt file in Notepad or whatever editor you want, and let's do Control F here to do a control find, and we're just going to look up player session ID because we did log it, or we should have logged it. Click on or press enter to click on find next, and yeah, it looks like everything is good. We have not only the player session ID as you can see down here, but we also have the player ID. And actually if we click out of this find next window and just like briefly kind of remember the values of the player session ID and the player ID, I noticed like kind of briefly what they look like. Now if we go back to the GameLift dashboard, and we expand this player ID, make it a little wider so that we can actually see the entire value. It pretty much lines up, I believe. I believe it lines up with this last player session, the bottommost player session, the values that we just saw in this text file, yeah. So let's close out of this, so that makes sense. Now let's go back to File Explorer and actually look at the GameLiftTutorial_2 text file and do the same thing. Control Find, look up player session ID, click on Find Next or press Enter, and do the exact same thing. Compare the player session ID value here as well as the player ID value to the ones you see in this game session page in the GameLift dashboard. So just taking a quick look, just trying to memorize as much information I need to, and yeah, it seemed those values do seem to correspond with this topmost player session, so that all looks good. But there is an issue that we will address in the next part of the tutorial. This game session is currently active, and if we refresh the page, this game session is still active, as you can see here by where it says status. It will always be active until there's a spot interruption, the fleet is terminated, or the fleet capacity is scaled down. Now, you absolutely do want to terminate game sessions, which we will be doing in the next part of the tutorial, but we still have one more thing to test. When a game ends, will the client have to sign back in upon going back to the main menu map? The answer should be no. To test this, since there's no way for the server process itself to terminate, we have to manually do it. So, like I mentioned earlier, let's go to the scaling tab, but there is no scaling tab here because we have to go to the actual fleet again. We're in the game session, so go back to the fleet, and then go to the scaling tab this time, and then scroll down to where it says auto scaling policies, and by where it says manually adjust the desired instance count, change this number from 1 to 0. And now, because you changed the number, you'll see a check mark appear. So to apply these changes, click on that check mark. Now, if you have full protection on for your fleet's protection policy, this will not work because GameLift will only scale down, GameLift will not scale down active instances even if there are no players in them, no active player sessions in them, in a fleet with full protection on. So in that case, you may even have to go as far as terminating the fleet by clicking on actions and then terminate fleet. But I do not have full protection on for this tutorial, so this should work for me. Go back to your Unreal Engine game clients by pressing Alt-Enter, Alt-Tab, and then select your Unreal Engine game client windows. And this may take a while, so just wait. It could take a few minutes. Okay, so once the EC2 instance that hosted that server process that the clients were just in shuts down, if everything worked okay, you should have been redirected to the main menu map without having to re-authenticate yourself. And just to make sure things are working, just for one client only, just quickly start and cancel a matchmaking request by clicking the button once and clicking again, because the fleet capacity was scaled down to 0 instances. So a new match can technically still be made, but there won't be any server processes to host it. So the clients won't be able to ever connect to anything. Anyways, it all seems to work, so let's close out of these two game clients. And then let's refresh this fleet page in the GameLift dashboard, and now you will notice that there are 0 active instances and therefore 0 active servers. And you can even check the events tab to make sure that no errors occurred while shutting down. And if what just happened, like what we just tested, did not occur the way that you just saw on my screen the last 10, 20, or 30 so minutes, then that means there's either a problem on the client build or on the server build. If it's on the client build, that's not bad because you just have to make changes to the client, repackage it, and retest it. But if there was a problem on the server side with the build currently on GameLift right now, then you have to make changes to the server, repackage it, re-upload it to GameLift, and make a new fleet, unfortunately. But do not worry, I will be in the comments section below as well as on Discord to answer any questions that you may have. And even when testing the client again, you will have to increase the number of desired instances in the auto scaling policies in the scaling section back up to 1, or make a new fleet if you had to terminate this fleet earlier. And also, let's quickly go to actions edit fleet. Not going to actually change anything, but just going to show you guys before you manually scale the fleet capacity back up or start a new fleet. Don't be afraid if we scroll down here to the server process allocation section. Don't be afraid to allocate more server processes for each instance on the fleet so that you have more attempts to test the client and server, since right now the game sessions are not being recycled. So once all the server processes in the instance are hosting an active game session, a match can no longer be hosted on that instance because all the server processes are being used. So in that case, you will have to again either manually scale down and back up the fleet or terminate and remake the fleet. And let's click on cancel to get out of here. Now let's quickly check DynamoDB, specifically in the matchmaking tickets table. Click on refresh and you should see 2 items of type matchmaking succeeded as expected. And if we go to the CloudWatch logs, let's look at the track events log group, specifically for the track events Lambda function. And let's find the log stream that occurred around the time that the clients got into a match. So I believe for me it was around 8:15. So let's click on this log stream and expand the log messages that don't start with the word start and the report. Expand the messages that start with the timestamp followed by the word info. So if we click on this, expand this matchmaking ticket log message, you'll notice that this is a ticket in matchmaking searching status. And if we expand the next log message, you'll see that it already went to potential match created. Kind of weird because we didn't see the other matchmaking ticket yet, but you'll notice that inside this potential match created event that one of the tickets in the event aligns with the ticket that we just saw in matchmaking searching status. So I'm curious now. So let's go back to the track events log group. Now these log messages may not be out of order like they are for me right now. Let's click on the log stream right above the one we just checked. Again, expand the message that has the word info by it. Yeah, so you see that there's a ticket here in matchmaking searching status, and this ticket ID, I believe if we go back, so I'm just going to remember a little bit about it. Go back to the log stream from before that we're just looking at. That ticket ID we just saw in matchmaking searching status, that new ticket we just saw, if we go back to the potential match created event, it's the exact same ticket ID inside this event. So let's go back to that newer log stream, and let's look at the last log event inside this log stream, and this one is of type matchmaking succeeded. So see, this is why I kind of decided a long time ago to just store the final result event notifications in DynamoDB, the events that can only happen once. For example, matchmaking succeeded won't happen twice for these 2 tickets. Same with matchmaking canceled, failed, or timed out. Once a ticket reaches one of those states, the lifespan of the ticket is technically finished. There will be no more events involving that ticket. So notice, actually this is a good example because you could see the order of the SNS messages arriving to the Lambda function, subscribe to the SNS topic, does not always coincide with the order that they were published / delivered by GameLift. And the very last thing we're going to do in this tutorial is go back to Visual Studio and let's comment out the log statement in the main menu widget C++ class and the on-poll matchmaking response receive function. So again, comment out this log statement where we print out the player session and player IDs, because we now know we are indeed sending those values to the server when we connect. And once you have done that, go ahead and build your project. And ladies and gentlemen, that concludes this part of the video. All of the code written in this video will be in a repository in GitHub linked in the description below, so don't worry. And thank you all for watching. If you enjoyed the video, then please comment, like, and subscribe. Follow us on all of our social media pages. Join our Discord, support us on Patreon, because any donation amount helps, no matter how much. And the next part will be the last part of the tutorial series involving coding. So after the next video, we should have the completed tutorial project, which will end up having all the server functionality needed for terminating game sessions, activating player sessions, managing backfill, assigning teams, and assigning winners. So see you guys in part 8.